Hello everyone, good evening, good evening. Are you guys there? Sorry for the delay. It was a technical glitch for some time. I don't think that would have taken much of your time. We're only, yes, so if you can hear me, can you please write something so that I know that you are listening to me and I will be sure. Yes, good evening everyone, good evening, good evening. Is everything good? Am I clearly audible? Are you able to hear me clearly? There should be no confusion. Anyone please? Yes. Okay. Thank you so much. Very nice. So hello everyone. Welcome to the YouTube channel of AgriAddict. Today is Soil Chemistry ka MahaMarathon, as we all know. So just for your information, soil chemistry is my most favorite subject. So I have taken this portion with special request to the AgriAddict team. So I hope you will enjoy it, because soil chemistry is the, you can say it is the building block of all the other aspects, the main pillar of soil science, because chemistry only determines fertility and all the other aspects. So soil chemistry is very nice. It is a bit complex, but once you understand the concepts, I don't think it is much problematic. Chemistry is really good, but the problem is like not much difficult questions come in ICAR JRF. The question level is not that high. I have brought the previous year questions for you also. After this marathon is over, we will solve some questions to give you first hand तो कैसा आपका preparation रहा, you will get a first hand notice of that. So I have taken that also. So I don't think soil chemistry will be a major problem for you, but understanding soil chemistry is very important to understand the whole of soil science. All right. So without further much time waste, we will start. So I think by now you all know me. I have done my UG from GKVK, then my PG from Central Rice Research Institute, and currently I am a PhD student in ICAR IRI in New Delhi. And so let's start. We all know the soil chemistry. So the soil chemistry will start from colloid only. Properties of colloid. Yes. So this table is extremely important. I have taken this table specially for you. I have modified it. This information in this manner, I don't think you will get anywhere. But yes, so let's dive into it. So true solution, colloid and suspension. These are the three types, as we all know. So in among the particle size, what is the difference? It will be less than 1 nanometer. Then 1 to 1000 nanometer is colloid, and greater than 1000 nanometer will be suspension. We all know the nature of true solution is homogeneous. For colloids, it is heterogeneous, and for suspension, it is definitely heterogeneous. Then appearance is clear and transparent. For colloid, it is translucent, and for suspension, it will be opaque. We know it is opaque. Sir, should I get full length mock from IRI toppers? Will I get good level mocks there? I have to practice. I'm an aggressive student too. Please concentrate on this now. We will talk about mocks and everything later. All right. So the stability, highly stable, particles never settle. This is moderately stable. This is totally unstable. This is an important point. I think you all know already all this. This is important point and this is important point. So you have to be very careful. Tyndall effect. Tyndall effect, I think you all know, it is a scattering of light. So true solution does not scatter light because light will pass through it, because the particles are so small, and after the hydration and solution, the light can directly pass through it. Whereas for colloid, it is scatters light visibly and it exhibits Tyndall effect in the major way. This is a very important point. And suspension may scatter light initially, but often blocks it as particles settle. So suspension, so think of it as simply particle size jitna bada hota jayega, utna it will go from true solution to colloid to suspension. All right. So here are the examples. I think you know. Dissolved fertilizer in water, salt water. These are the true solutions. Whereas milk is one of the major example of colloid. Then also fog. And for us, for soil science students, it is clay humus complex. And suspension, we all know, muddy water, chalk powder, and so on. So what is colloid now? What is colloid? Colloid, this is in all the ISSS, in all the treatises, wherever you go. Colloidal system is the heterogeneous mixture. You have to focus on the keywords जहाँ से question आ सकता है. Yes, questions will come from these words. So please be focused on these words. Colloidal system is heterogeneous mixture of at least two phase system in which one phase is dispersed in a state of fine subdivision to another phase. So colloidal system is a heterogeneous mixture of at least two phase. So जो two phase है उसमें one phase is finely subdivided, and it is embedded in another medium which is continuous. All right, we all know the definition of colloid. So one phase, the dispersed phase, is dispersed in a fine state of subdivision in another medium which is called continuous or the dispersion medium. Here this is extremely important. I would like you to make a note if you are making a note, otherwise you can read from this PPT. The term colloid was given by Thomas Graham in 1861. This question I have seen myself in 2 or 3 PYQs. Mostly they ask in maths the following. They will give many scientist names and the terms. So Thomas Graham, you have to remember, who coined the term colloid. All right, moving on. Colloidal system can be divided into two groups. Now we are entering deep into colloid. Colloidal system can be divided into two groups on the basis of their affinity to the solvent, on the basis of their affinity to the dispersion medium. I told you, right? This finely subdivided particle, this is the dispersed phase, and the continuous is the dispersion medium. So depending on the interaction of the two, depending on the interaction of the dispersed phase and the dispersion medium, we have two types, two groups. One is called lyophobic, another one is called lyophilic. For your convenience, I have written the meanings here. Phobic, we all know, it is hating, like hydrophobic. Hydrophobia happens when rabies happens to you. So it is, you are fearful of water. So here solvent hating and solvent loving is lyophilic. Soil colloids are neither truly hydrophobic nor truly hydrophilic. This line is also very important. That's why I have made it in yellow for you. This line is also very important. Soil colloids are neither truly hydrophobic nor truly hydrophilic because it has affinity to water, and hydrophobic because it is flocculating nature with addition of small amount of electrolyte. All right. So here हमको lyophobic or lyophilic we got to know, but we have to see what is lyophobic and lyophilic because question might come, you know, question might come. So एक है phobic, एक है philic. All right. इसमें से always remember, lyophilic colloids are also called reversible colloids. Why? Philic are called reversible. Why? Because say there is a colloidal system, जिसमें the solvent is water and the dispersed phase is something. All right, it is something. If it is lyophilic, if it is solvent loving, so it will form the colloid very easily. It will form the colloid very easily. But if it is lyophobic, lyophobic का मतलब है जो पानी है, जो dispersion medium है, it is fearful of that. So it does not want to make bond with that. It is hating the solvent, right? In that case, उसका क्या होगा? It will coagulate and it will settle down. Here you can see it will coagulate and it will settle down. In that case, making a lyophobic colloid is very difficult because ordinarily it will not form the colloidal solution. It will not form the colloidal system. Ordinarily lyophobic colloid हम बना नहीं सकते until and unless we are giving some special treatment to it. Why? Because ordinarily if we add any lyophobic substance, it will coagulate and it will precipitate. And whatever you do, you cannot make a colloid. Whereas in case of lyophilic, you can make the colloid and again it can precipitate. Again with the removal of the electrolytes, it can again form the colloid. That is why it is called reversible. So in exam question might come, which is a reversible colloid? That will be lyophilic. All right. And which colloid needs special treatment for colloid formation? That would be phobic. So general properties of soil colloids, this I think all of you are reading from your UG second or third year also. There is nothing to do with that. So the first property is of course size. Size is very important. Colloidal particles are too small to be seen with ordinary light microscope, but are visible with ultra and electron microscope, definitely. They are larger than atomic dimension colloidal particles are non-permeable through semi-permeable membrane. All right. Now, the next most important property is Brownian motion. What is Brownian motion? Due to unbalanced impact of the liquid dispersion medium molecules on the colloidal particles, colloids are in perpetual zigzag motion. यानी कि colloidal particles, since they are not so small as like true solution, so when these colloidal particles will be in the solution, they will get hit by the solvent molecules. When they are in the colloidal system, जो dispersion medium जो है, जो solvent है, उसका molecule के साथ there will be collisions, and that collision will result in a zigzag motion. So the colloidal particle will move like zigzag motion. This is also called thermal motion, right? So that is Brownian motion. Definitely, I think with your common sense only you can understand. If you increase the temperature, if you supply heat, kinetic energy will increase, and this collision will increase, and this Brownian motion will increase, right? Flocculation and dispersion. Addition of flocculating agents like electrolytes causes colloidal particles to be mutually attracted to each other through cationic bridge. All right, cationic bridge क्या है हम बाद में देखेंगे, definitely, and it is settled in the form of floccules, right? Flocculating power of cations depends on the valency and the hydration energy of the exchangeable cations. This is very, very important. This statement can come in statement based question. This statement can come as assertion reason as well. So divalent and polyvalent cations have the higher flocculating power, we all know. I cannot see any comments. Can anyone tell what is this series called? Lyophilic कहाँ से series बन गया भाई? Yes, it's not exactly lyotropic series. This is actually the series of flocculating power only, but it is similar to lyotropic series. Lyotropic series क्या है वो भी हम देखेंगे. That is dependent on the exchange power, right? So highly hydrated monovalent cations have lesser power, and in general flocculating power of the cations follow the order of Al, Ca2+, Mg2+, K+, Na+, and lithium. This question I have asked in the group of elite batch. I remember. Which of the following cations has the highest dispersive power? In that, lithium would be the answer if lithium is there in the option. Why? Because simple periodic table that you have read in your class 11. Lithium, sodium, potassium, rubidium, cesium. This is the first group, right? So we know as we go on the period, the radius of the atoms increases. This is common knowledge. लेकिन soil के केस में क्या है? For soil it will be reverse. Why? Because soil is a hydrated system. In soil there is soil water. So जब वहाँ पे water है तो उसका hydrated radius हमको लेना पड़ेगा, है ना? We have to take the hydrated radius. Hydrated radius का trend क्या होता है? It becomes opposite. Why? Because जो atom जितना छोटा है उसका hydration से shell उतना बड़ा है. So the hydrated radius becomes higher. So radius along the down the group, radius of unhydrated cations increases, but radius of hydrated cations decreases. Hydrated cation का radius is opposite to that of unhydrated cation. So soil is a hydrated system. वहाँ पे जब हम बात करेंगे, lithium will have the biggest size because of its hydration energy, because of its bigger hydration shell. That is why it will have the highest dispersive power, followed by sodium. All right, moving on. Now, soil colloids ka division. How much marks is required for general category to get a seat in IRI Delhi? That is a very good question, but that differs from year to year. In my year, it was 406. All right. So next year it became less. Now I think you can मान के चलो general category and state quota का अगर problem नहीं है, if you are not a Bengali. So probably 380. You can target 380, 390 like that. So soil colloid can definitely be divided into two parts, as we all know, inorganic colloid and organic colloid. So inorganic colloid has crystalline silicate clays. Iska example is very important, kaolinite, illite, etc. Non-crystalline silicate clays, uska example hai allophane and immogolite, as we all know. Iron and aluminium oxide, jiska example hai gibbsite, goethite, etc. And the next part is we all know. Next part we all know is organic colloid. Yes, 406. Kya bhai? So organic colloid has humus and it is divided into fulvic acid, humic acid and humin, as we all know. And among these three, the molecular weight increases in this direction, and also the persistence in system in nature in soil increases in this direction. Fulvic acid is soluble in all. It is soluble in water, it is soluble in acid, it is soluble in alkali, whereas humic acid is soluble in only in alkali and humin is insoluble. All right, यहाँ तक I think clear है. Moving on, inorganic colloids is very important. We all know inorganic colloids is very important in soil. So inorganic colloids में क्या आता है? Aluminosilicate, layer silicate clays are the main inorganic colloidal constituents in soil. We all know that, there is nothing new. Silicates are the most common mineral in the earth crust, which account for more than 90%. Silicates are the most common mineral in earth crust, which accounts for more than 90% of the earth's crust. It occurs as primary minerals and as secondary minerals both. अब ये क्यों है? Why is that? Why is that का आंसर छुपा है in the composition of earth crust. We all know earth crust का composition, highest is oxygen, second is silicon. So silicate is combination of these two. ये दोनों अगर crust में सबसे ज्यादा है तो bond तो ये दोनों ही बनाएगा ना, because they have the highest composition. So silicate is the combination of silicon and oxygen, as we all know, and therefore it occurs for more than 90% of the earth's crust. It occurs as primary minerals, it occurs as secondary minerals as well. है ना? There are different types of non-crystalline silicate clays like allophane and immogolite. Iron and aluminium oxides may also be present in colloidal size fractions. So inorganic colloid में क्या क्या आया? Aluminosilicate, layer silicate clays सबसे important है, ये आया. दूसरा आया non-crystalline जो silicate है, crystalline, then non-crystalline, and then finally iron and aluminium oxides can also be present in the colloidal size fraction. All right. Organic soil colloids, humic colloids is the main fraction of the soil organic matter. इसका सबसे important part जो है that I have highlighted for you, CEC of humic colloids which is pH dependent. हमेशा याद रखना, CEC of humic colloid is always pH dependent and it can range from 200 to 50 centimole positive charge per kg of soil or it can go even higher. हमारे सीनियर्स हमको बोलते थे कि ऐसा अगर कभी क्वेश्चन आया ऑर्गेनिक मैटर रिलेटेड, उसका CEC रिलेटेड, तो जो ऑप्शन सबसे ज्यादा रहेगा उसको मार्क करके आना. इफ इट इज 350, इफ इट इज 300, डजंट मैटर, सबसे ज्यादा जो है उसको मार्क करो और आगे बढ़ो, है ना. तुम लोग अब ऐसा मत करना कि 900, 1000 को मार के आओ, नॉट दैट, बट विद इन अ रेंज ऑफ से 350, 400 सबसे ज्यादा जो है यू कैन मार्क दैट. All right, so now this according to me is the most important table of all of your ISSS and everywhere. This table you should remember as it is. This is very important. Every aspect of this table is question worthy. This is there in old ISSS, this is in new ISSS, this is in SC Datta sir's book. It is everywhere. जहां से भी पढ़ना है इसको पढ़ना है. All right. अब इसमें क्या क्या पढ़ना है? Of course the name, then of course the formula. These two are extremely important, and then the examples. Formula is optional. सारा formula याद रखना possible नहीं है. Do not go for it, but you have to remember this name. Very important both for JRF as well as SRF. All right. अब ये जो formula है, this SiO4 minus, I think you all know how it comes. Still I will tell. This is one Si. ये एक ऑक्सीजन है, दो ऑक्सीजन है, तीन ऑक्सीजन है, and the oxygen that is protruding out, that is out from the board plane, that is the apical oxygen. So there are 4 oxygen. Since Si is 4 plus, oxygen 4 oxygen का मतलब है -8. So -8 plus 4 is equal to -4. So this -4 charge is there. SiO4 4 minus, है ना. In the same way, you can find out this formula for all the structures if you remember the structure. Structure अगर याद है तो you can calculate the formula. लेकिन एग्जाम में ये करने मत जाना, बिकॉज एक क्वेश्चन के लिए यू कैनॉट अफोर्ड इतना टाइम, यू कैनॉट अफोर्ड. ऑलराइट, सो फॉर्मूला याद होने चाहिए. अगर लाइक इन क्रिटिकल केस याद नहीं आ रहा है एट दैट टाइम, यू कैन डिड्यूस द फॉर्मूला. लाइक हियर ऑल्सो इट इज वेरी सिंपल. 2 SI यहाँ पे है, सो SI2 हो गया, देन ऑक्सीजन इज 1 2 3 4 5 6 और ये एक कॉमन ऑक्सीजन है 7, सो इट विल बी Si2O7. चार्ज कैसे बैलेंस करे? 7 2s are -14, Si2 +8, -14 +8 हो जाता है -6. ऑलराइट, लाइक दिस वे, you know. But these names are very important. You have to remember the names. Here also for cyclosilicate, इसका भी अगर फॉर्मूला याद नहीं आ रहा है, how will you calculate? बहुत आसान है. एक ऐसा हेक्सागन बना लो, एक ऐसा स्टार बना लो. This is like the star of that Israel flag, no? This is also called David star. Anyhow, एक ऐसा स्टार बना लो, then you can calculate yourself. Silicon is 1 2 3 4 5 6, so silicon 6 हो गया. Now you calculate the oxygen. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18, एकदम बराबर, कोई प्रॉब्लम नहीं है, सारा हिसाब आ भी गया, so everything is fine. Likewise, you have to remember this, especially inosilicates and double chain and single chain. Remembering this double chain is a bit difficult. You have to remember. Phyllosilicate का तो याद होना ही होना चाहिए. If you don't even remember phyllosilicate, फिर तो बहुत शर्म की बात है. Yes, so moving on, and this is the tectosilicates also. Tectosilicate का formula भी बहुत important है. Questions come from this. All right, moving on. These are the examples. We all know that. Now comes the most important part, that is called phyllosilicates. Phyllosilicate में there is one easy question for you. Phylo का मतलब कोई बता दो. I will drink some water. Please tell me the meaning of phylo and we will move ahead. क्या होता है phyllosilicate? You all know, definitely you all know. Exam में 1 महीना बचा है. It is not layer, Pavan. It is not layer. Phylo का exact मतलब क्या है? Phylo you have found in somewhere else also. In soil biology there is a term with phylo. उसको याद करो. Then you tell what is phylo. Yes, it will be sheet or it will be leaf like. Phylo, actually phylo का like literal meaning होता है leaf. That's why phylosphere हम पढ़ते हैं, coined by Dr. Jacoba Ruinen. We all know phylosphere, the term phylosphere. तो पहले जैकोबा रुइनन ने जो टर्म दिया था उसका मतलब था सिर्फ लीफ सरफेस में जो होता था, दैट वाज फाइलोस्फीयर. लेटर दैट डेफिनेशन वाज एनहांस्ड एंड उसमें पूरा अपर जो सॉइल के अबव ग्राउंड जो पोर्शन है पूरा लिया गया. पहले इट वाज ओनली लीफ, सो दैट फाइलो मींस लीफ. इट इज लीफ लाइक मतलब लेयर लाइक. यू आर करेक्ट. लीफ लाइक मतलब इट इज शीट लाइक. इट इज ऐसे in 2 dimension. Yes, it is Greek word. Yes, exactly correct. So aluminosilicate, layer lattice clays or phyllosilicates are derived from primary silicate minerals. These are the most important, है ना? Most important, इसको याद रखना. Phyllosilicates are composed of 2 kinds of sheets, tetrahedral sheet and octahedral sheet. All of you know this. This is nothing new. Tetrahedral sheet क्या है? Tetrahedral sheet जानने से पहले हमें जानना पड़ेगा tetrahedral क्या है. टेट्राहेड्रल यानी कि sp3 hybridization. I think you all are good with your chemistry, 11-12 का chemistry. This is एकदम basic. sp3 का सबसे बेस्ट एग्जांपल है मीथेन, राइट? हम लोग ऐसे ड्रॉ करते थे. So when there sp3 hybridization is there, tetrahedral is the structure which is most geometrically stable, and in this universe everyone wants to be geometrically stable and thermodynamically stable. सबको जिंदगी में स्टेबल होना है. So this is the most geometrically stable structure. और इसका अगर कैलकुलेट करके निकालोगे तो all these angles between the bonds comes 109 degree and 28 minutes. ऑलरेडी सॉयल वाटर हैज बीन कवर्ड, यस, एज अ मैराथन. उसमें यू माइट हैव सीन वाटर का स्ट्रक्चर. वाटर का अगर हाइब्रिडाइजेशन देखोगे, वाटर का हाइब्रिडाइजेशन इज ऑल्सो sp3, मतलब वाटर भी टेट्राहेड्रल होना चाहिए था, लेकिन इसके पास तो दो ही हाइड्रोजन है, 4 बॉन्ड तो है नहीं. सो हाउ इज द स्ट्रक्चर? द आइडियल स्ट्रक्चर शुड हैव बीन ऑक्सीजन है, एक लोन पेयर है, दूसरा लोन पेयर है, फिर 2 हाइड्रोजन है. दिस इज द आइडियल स्ट्रक्चर ऑफ वाटर. लेकिन वही प्रॉब्लम में फिर से वही दिक्कत, नेचर में नथिंग इज आइडियल. अब क्या प्रॉब्लम आ गया? These lone pairs, the repulsion between lone pairs is very high. जितना बॉन्ड पेयर रिपल्शन है, उससे कई ज्यादा लोन पेयर रिपल्शन इज देयर. अब इन दोनों की रिपल्शन की वजह से क्या हुआ? दिस थिंग इज रिपल्सिंग, सो एज अ रिजल्ट दिस थिंग इज उनका इट इज गेटिंग स्क्वीज्ड. सो दिस एंगल ट्रांसफॉर्म्स फ्रॉम, एक्चुअली होना चाहिए था 109.28, वो ट्रांसफॉर्म होके 104.5 डिग्री हो जाता है. ऑलराइट. So I think you knew this, but ऐसे बातों बातों में आया तो चला आया. So this is a tetrahedral. अब हमारे सॉइल में सिलिकेट से हमारा बात होगा. So उसमें जो कैटायन है, कैटायन को हम बीच में रख देंगे. That will be a silicon, and we will have 4 oxygen. Right? We will have 4 oxygen. This is a SiO4 tetrahedron. अब इसमें क्या प्रॉब्लम है? See, ऑक्सीजन का टोटल आउटर शेल में अगर इलेक्ट्रॉन कॉन्फ़िगरेशन याद करोगे, आउटर शेल में होना चाहिए 6 इलेक्ट्रॉन. तो क्या इनके पास 6 इलेक्ट्रॉन हुआ? 1 2 3 4 5 6 7 8. आउटर शेल में 6, लेकिन टोटल इज 8. वी नो ऑक्टेट रूल. सो ये जो कोवेलेंट बॉन्ड है, कोवेलेंट बॉन्ड वी ऑल नो, ये एक इलेक्ट्रॉन देता है, ये एक इलेक्ट्रॉन देता है. सो टोटल नंबर ऑफ इलेक्ट्रॉन फिर से काउंट करते हैं, 1 2 3 4 5 6 7 8. अब 8 हो गया. सो ऑक्टेट इज फिल्ड. नाउ वी हैव टू कैलकुलेट ऑक्सीजन का खुद का कितना इलेक्ट्रॉन हो रहा है. वो क्या 6 हो रहा है कि 6 से ज्यादा? 1 2 3 4 5 6 7. वो हो रहा है 7, जो कि होना चाहिए था 6. दैट इज व्हाई देयर इज 1 एक्स्ट्रा चार्ज इन ऑल द ऑक्सीजन, एंड दैट इज रिटन एज माइनस. सो इसका फॉर्मूला हो गया SiO4 4-. ऑलराइट. आई थिंक इतना तक सबको क्लियर है. इतना तक सबको क्लियर है? इफ यस, प्लीज ड्रॉप अ थम्स अप. मुझे भी, आई विल ऑल्सो गेट अ बिट मोटिवेटेड. यस यस, आई थिंक इतना तक सबको क्लियर है. हियर यू कैन सी दिस फोटो इज फ्रॉम न्यू ICCS. यू ऑल नो डॉक्टर एस सी दत्ता चैप्टर. दिस फोटो इज फ्रॉम न्यू ICCS, है ना? This photo is from new ICCS. So here you can see 4 oxygen atoms are there, and बीच में there is 1 silicon. अब ये जो 3 ऑक्सीजन एटम है, this looks more or less in the same plane, right? That is why these are called basal oxygen atoms. बेस में है ना? बेस में है तो इट्स बेसल. और ये जो प्रोट्रूडिंग ऑक्सीजन है, जो प्लेन से ऊपर है, that is called apical oxygen atom, right? यहाँ पे आप लोग देख सकते हैं in this photo, these are the basal oxygen atoms, whereas these are the apical oxygen atoms. अब ये apical oxygen atom से we all know linking होता है ना? So tetrahedral, हम तो सिर्फ tetrahedron पढ़े, single tetrahedron we got to know what is a tetrahedron. अब tetrahedral sheet क्या है? Tetrahedral sheet is nothing but, since मैं यहाँ पे दिखाया कि ऑक्सीजन का चार्ज फुलफिल नहीं हो रहा है, there is minus, and this whole compound is having 4 minus charge. माइनस और प्लस चार्ज लेके भी जिंदगी में कोई स्टेबल नहीं हो सकता. उसको फर्दर स्टेबिलिटी की जरूरत है. फॉर दैट रीजन इट विल स्टार्ट शेयरिंग द ऑक्सीजन. ऑक्सीजन का शेयरिंग चालू होगा, जिससे क्या होगा? ऑक्सीजन के ऊपर जो इलेक्ट्रॉन लोड है, जो नेगेटिव चार्ज का लोड है, दैट विल डिक्रीज. ऑलराइट. इनका एक ही मकसद है. दिस SiO4 4- हैज ओनली वन गोल इन लाइफ, दैट इज टू बिकम स्टेबल. अब वो स्टेबिलिटी के लिए क्या चाहिए? पहले टेट्राहेड्रॉन बनाना है, वो बना लिया. बनाने के बाद अब देखा जा रहा है ऑक्सीजन इसमें स्टेबल नहीं हो पा रहा है, बिकॉज ऑक्सीजन इज हैविंग वन एक्स्ट्रा नेगेटिव चार्ज. ये नेगेटिव चार्ज को हटाने के लिए इट स्टार्टेड शेयरिंग इट विथ अदर टेट्राहेड्रॉन. तो क्या हुआ? सपोज दिस इज अ टेट्राहेड्रॉन, तो इट स्टार्ट्स फॉर्मिंग इट, ऐसे शेयर करते 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 इट स्टार्ट्स फॉर्मिंग लाइक दिस इन 2 डायमेंशन. 2 डायमेंशन क्या होता है? दिस बोर्ड इज अ 2 डायमेंशन. दिस इज द लेंथ, दिस इज द ब्रेथ. सो इमेजिन बीच में एक टेट्राहेड्रॉन है, वो हर तरफ ऐसे 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 करके, हर तरफ ऐसा करके इट मेड अ बॉन्ड, है ना, हर तरफ में कर लिया इन 2 डायमेंशन, दैट इज इन 2 डायमेंशन, दैट इज कॉल्ड अ शीट, है ना। यहां पे जो टेट्राहेड्रल शीट है, दिस इज नथिंग बट, टेट्राहेड्रल शीट इज नथिंग बट, ये जो टेट्राहेड्रॉन है, जस्ट टू बिकम स्टेबल, ये बेसल ऑक्सीजन को शेयर करके 2 डायमेंशन में इट मेक्स अ शीट लाइक दिस, यू नो। शीट का मतलब आई थिंक यू नो, मान लो दिस इज अ शीट, so it will have all the basal oxygen in this same plane, that will be a sheet, that will be a tetrahedral sheet. Now this sheet has what, this sheet has all the जो apical oxygen जो बच गया, all those apical oxygen are protruding from this sheet in this layer, in this line, है ना, somewhere here imagine करो, all the apical oxygen are there, in that apical oxygen उसको common oxygen बना के there will be the octahedral sheet again in the upper part, है ना। This is the explanation जो मैं अभी तक इतना चिल्ला रहा था। 3 or 4 oxygen atoms of each tetrahedron are shared by 3 neighboring tetrahedra, also called corner sharing. This term is important, इसको याद रखना, tetrahedra में corner sharing होता है। The 4th oxygen atom of each tetrahedra is not shared. This arrangement gives hexagonal symmetry to sheet in which rings of 6 oxygen atoms appear. So अभी तक मैं जितना बोला, everything is compiled in this. This is also from new ISSS. If you see all these single units, वो एक के साथ एक शेयर किया and it forms a hexagonal ring like structure, ऐसा बना के 2 डायमेंशन में it is called sheet. Always remember 2 डायमेंशन में sheet होता है ना। Now what is octahedral sheet? I think you all know. You all know what is octahedral sheet. The oxygen atoms and the hydroxyl groups lie in 2 parallel planes with Al or Mg atoms between these planes. The projection of sheet indicates that oxygen atoms and hydroxyl groups on hexagonal. So this is a octahedron. Octahedron ये फोटो देख के मे भी समझ में ना भी आए, I will draw a simpler octahedron for you. So actual में octahedron looks like there will be the central metal cation. This is a simpler octahedron. उसमें क्या होता है, this is the middle part, middle का जो square है, this is this, उसके ऊपर एक ऑक्सीजन रहता है just like tetrahedra, और उसके नीचे एक ऑक्सीजन रहता है, हाँ, and in the middle tetrahedra में जैसे 3 रहता है, in this there will be 4, that is a octahedra, है ना। So now this is also from new ISSS. Here you can see octahedron का जैसे मैं दिखाया, octahedron structure, they form the sheet by edge sharing. Tetrahedron forms the sheet by corner sharing. Octahedra forms the sheet by edge sharing. Yes, all right. अब octahedra में भी there are 2 types. Tetrahedra में ऐसा कोई समस्या नहीं है. Tetrahedra is single type only. वो 4 लोगों के साथ बॉन्ड बनाएगा, वो अपने जीवन में खुश है. But octahedra has 2 types. You all know. One is trioctahedra, one is dioctahedra. अब ये क्या है? Trioctahedra is octahedron shares all the 6 edges with 6 neighboring octahedra when there is a divalent cation at the center of the octahedron. All the 3 sides are occupied by cations. All these statements are very important. I have taken only the important statements जहाँ से question आता है. All the extra parts I have cut off. है ना? Dioctahedral sheet, these are the trivalent cations. ये हमेशा याद रखना. Trivalent cations will form di. Divalent cations यहाँ पे कहीं पे लिखा नहीं है. Divalent cation will form tri, है ना? With 3 neighboring octahedra, 2 out of 3 octahedral sites, 2/3 of the octahedral sites are filled. 2/3 of the octahedral sites are filled. अब इसका क्या मतलब है? इसका मतलब हम यहां से समझते हैं. This is a picture of trioctahedral. Trioctahedral, तो you can see ये एक single octahedra है. This is also a single octahedra. They have shared the edges and they have made a octahedral sheet in 2 dimension. All right, very nice. In this you can see all the central cations are filled. All are filled, right? Here you can see 2 are filled, then 1 is empty, then 2 are filled, then one is empty. That is called, this is called dioctahedra because only two are filled. Okay, अब इसको याद रखने का सही तरीका क्या है? ऑक्टाहेड्रॉन जैसे मैं यहाँ पे ड्रॉ किया था, here you can see there are 6 anions, right? 6 anions are there. ठीक है, 6 anions are there. So 6 minus charge को हमें बैलेंस करना पड़ेगा because mostly these are hydroxyl groups only. और अगर ऑक्सीजन भी है so there will be 1 minus only, there will be single minus only, 2 minus नहीं आएगा. So 6 anions है, उसका जो 6 minus है उसको हमें बैलेंस करना पड़ेगा. तो 6 माइनस बैलेंस करने के लिए हमें +6 लगेगा. अब +6 Mg2+ का कितना एटॉम दे सकता है? हाउ मेनी एटॉम्स ऑफ Mg2+ कैन गिव +6? दैट विल बी इनटू 3. सिंपल मल्टीप्लिकेशन है, 3 × 2 6. और अगर Al3+ है तो यू नीड 2 बिकॉज अगेन 2 × 3 6. ऑल राइट, आई थिंक डाइऑक्टाहेड्रा एंड ट्राइऑक्टाहेड्रा इज क्लियर बाय नाउ. अभी इसमें और इंटरेस्टिंग चीजें हैं, वी विल डिस्कस दैट. लिंकिंग ऑफ टेट्राहेड्रा एंड ऑक्टाहेड्रा, जो मैं अभी तक इतना टाइम से बोल रहा था, हाउ दैट लिंकिंग हैपेंस. लिंकिंग ऑफ टेट्राहेड्रा एंड ऑक्टाहेड्रा टेक्स प्लेस थ्रू एपिकल ऑक्सीजन. जो ऑक्सीजन बेसाल प्लेन में नहीं था, दैट ऑक्सीजन of tetrahedra will form the linking. This plane becomes common to both tetrahedra and octahedra. Here you can clearly see, this is a very brilliant picture. This is the tetrahedra, this is the apical oxygen. This oxygen is common to both the octahedra and the tetrahedra, and this plane is common to both of them. All right, this plane becomes common to both tetrahedra and octahedra, and connecting oxygen atom is shared by both tetrahedral and octahedral cations. All right, so हमें लिंकिंग भी समझ में आ गया. अब ये लिंकिंग, दिस आई विल कम लेटर. जब ये लिंकिंग हो जाता है, टेट्राहेड्रल शीट एंड ऑक्टाहेड्रल शीट दोनों का जब लिंकेज हो गया इन 3 डायमेंशन, देन इट विल फॉर्म अ लेयर. ऑल राइट, मेनी पीपल हैव दिस कॉन्सेप्ट अनक्लियर. उनको पता नहीं है लेयर क्या है, शीट क्या है. प्लीज डू नॉट गेट कंफ्यूज्ड. शीट का मतलब होता है कागज. शीट इज लाइक दिस, शीट इज 2 डायमेंशनल. शीट के ऊपर जब शीट का स्टैकिंग होगा, दैट विल फॉर्म अ लेयर. लेयर इज 3 डायमेंशनल. लेयर इज 3 डायमेंशनल. ऑल राइट, here also you can see this picture is also from new ICAR. Beautiful picture. 1 tetrahedra, 2 tetrahedra, between there is 1 octahedra. So this is one layer, right? And I was telling you 3 डायमेंशन जो होता है, दिस इज A डायमेंशन, दिस इज B डायमेंशन, और जो बाहर की तरफ आता है दैट इज C डायमेंशन. सो यहाँ पे जब स्टैकिंग हो रहा है, tetrahedral sheet and octahedral sheet both have formed the sheet in 2 dimension, that is A and B. So ये जो layer का है, this dimension is called the C dimension. That is why the interlayer space is also called C axis spacing. क्यों बोलता है उसको? Because C axis में stacking हो रहा है. So interlayer space जब हम calculate करेंगे, this is C axis spacing. That is why it is called C axis spacing. All right. यहाँ से अगर क्वेश्चन आया तो आई डोंट थिंक देयर विल बी एनीथिंग रॉन्ग. नाउ कमिंग टू दिस, दिस इज वेरी इंपॉर्टेंट. दिस इज आल्सो इन न्यू ICAR एंड इट इज सो ब्यूटीफुली रिटन, यू नो. यहाँ पे तुम लोग मुझे एक चीज बताओ, वन थिंग. दिस इज अ ट्राइऑक्टाहेड्रा, दिस इज अ डाइऑक्टाहेड्रल शीट. इन दोनों में से किसका लेंथ बड़ा होगा? हुज लेंथ विल बी मोर? एज शेयरिंग हो रहा है, देयर इज एज शेयरिंग. एज शेयरिंग करके एक शीट बन रहा है. हुज लेंथ इन B डायमेंशन, A डायमेंशन छोड़ दो, हुज लेंथ विल बी मोर? इस इन दिस B डायमेंशन, हुज B डायमेंशन लेंथ विल बी मोर एंड व्हाई? कैन एनीवन टेल? ट्राइऑक्टाहेड्रल लेंथ विल बी मोर. यस विपिन, वेरी गुड, बट व्हाई यू थिंक सो? क्या क्या कारण हो सकता है? इट इज वेरी इजी, इट इज ऑल, एवरीथिंग इज हियर ओनली. व्हाई ट्राइऑक्टाहेड्रल विल हैव मोर कैटायंस? मोर कैटायंस का क्या मतलब है? मोर कैटायंस से क्या होगा? More cations will lead to what? ऑल साइड्स आर फिल्ड, 3 आउट ऑफ 3 साइड्स फिल। हाँ, उससे क्या, लाइक हाउ इज द लेंथ इज इंक्रीजिंग? लेंथ इंक्रीज करने का कारण क्या हो रहा है भाई? अरे यार, इतना आसान तो है। ऑल द 3 साइड्स आर फिल्ड, इसका मतलब है कि इंटर कैटायोनिक जो रिपल्शन है वो ज्यादा होगा ना भाई। हियर यू कैन सी इतना डिस्टेंस है, द डिस्टेंस इज मोर, इन दिस केस डिस्टेंस इज लेस। तो इसके साथ इसका रिपल्शन, इसके साथ इसका रिपल्शन, इसके साथ इसका रिपल्शन, जनरली इट विल बी मोर, इट विल बी स्ट्रेच्ड आउट, right? It will be stretched out. That's why trioctahedral is always more in dimension in the B dimension. All right? अब इससे क्या होता है? इससे क्या होता है? इससे ये होता है कि टेट्राहेड्रा एंड ऑक्टाहेड्रा का जब बॉन्डिंग हो रहा है, लिंकेज जब हो रहा है, तब जाहिर सी बात है कि बोथ ऑफ दिस शुड हैव लगभग सेम डायमेंशन, राइट? We all know tetrahedral sheet is longer in length in B dimension. अब octahedra is shorter. अब shorter में trioctahedra is longer than dioctahedra. Dioctahedra is the shortest. अब इसमें क्या होगा? ये अगर लंबा है and ये अगर छोटा है, this sheet, so this guy will have to rotate somehow and become like this so that उसका linkage हो सकता है, right? This guy has to rotate and it has to form somehow, it has to form some shape जिसके वजह से अच्छे से लिंकेज हो सकता है, ठीक है? इन द केस ऑफ डाइऑक्टाहेड्रल शीट, डाइऑक्टाहेड्रल शीट में डिफरेंस इतना ज्यादा है, द टेट्रा, दिस फेनोमेनन इज कॉल्ड टेट्राहेड्रल रोटेशन। ये डिफरेंस इतना ज्यादा है, द टेट्राहेड्रल रोटेशन इज वेरी प्रॉपर, इट इज वेरी प्रॉपर, whereas in case of trioctahedral sheet दोनों का डिफरेंस ज्यादा नहीं है, सो द टेट्राहेड्रल रोटेशन इज नॉट दैट प्रॉपर, इसको उतना रोटेट नहीं करना पड़ रहा है, जिसकी वजह से क्या होता है, आफ्टर टेट्राहेड्रल रोटेशन इट विल फॉर्म दिस डाइट्राइगोनल कैविटी। दिस डाइट्राइगोनल कैविटी इज अ ग्रेट प्लेस फॉर फिक्सेशन ऑफ पोटेशियम। अनहाइड्रेटेड पोटेशियम का जो डायमीटर है 2.66, उसका जो डायमीटर है that is similar to this diameter of this ditrigonal cavity, जिसकी वजह से जितना अच्छे से रोटेशन होगा, पोटेशियम जाके उतना अच्छे से वहां पे फिक्स हो जाएगा एंड उसको निकालना would be very difficult. That is why dioctahedral mica or muscovite is less weatherable than trioctahedral mica or biotite. समझ में आया? ट्राइऑक्टाहेड्रल माइका, उसमें टेट्राहेड्रल रोटेशन इज नॉट दैट प्रॉपर, जिसके वजह से डाइट्राइगोनल कैविटी इज नॉट दैट प्रॉपर, दैट्स व्हाई पोटेशियम फिक्सेशन इज नॉट दैट हाई। whereas in case of डाइऑक्टाहेड्रल यानी कि मस्कोवाइट, जिसमें फेरोमैग्नीशियम नहीं है, मैग्नीशियम नहीं है, आयरन नहीं है, दैट विल हैव परफेक्ट टेट्राहेड्रल रोटेशन एंड इसमें पोटेशियम जाके बैठ जाएगा। समझ में आया? प्लीज if you would write, I would be very happy. यहाँ पे भी एक बार पढ़ लेते हैं। Tetrahedral sheet is longer than the octahedral sheet in B dimension. Here I have mentioned for you. If you had understood, please drop anything in the live chat, any thumbs up, anything. All right. During linking of the two sheets, the tetrahedral sheet must contract. See, this line I have taken directly from ISSS. मैं ISSS से लिया हूँ. I have not taken from any बहुत बड़ा कुछ जगह से नहीं है. So this is achieved by two adjacent tetrahedra rotating in opposite direction. This is called tetrahedral rotation. As a consequence, the hexagonal cavity changes its shape to ditrigonal cavity. यहाँ से क्वेश्चन आने का वर्ड से ditrigonal cavity, यहाँ से क्वेश्चन आने का वर्ड है tetrahedral rotation and दो opposite sheet ऐसे ऐसे करके कितना एंगल में घूमता है, 160 डिग्री. That also you should remember. This is 120 degree. After rotation it becomes 160 degree. मतलब 40 ज्यादा हुआ. So 40 कैसे ज्यादा होगा? It will be 20 degree on this side and it will be 20. जो मैं इतना देर से चिल्लाया वो भी यहाँ पे लिखा हुआ है. All right, moving on. तो I think structure लेके हमें अब और कोई दिक्कत नहीं है. Now we are coming to Goldschmidt's laws. We all know Goldschmidt's का law क्या है? You all तो definitely know. So इसमें ज्यादा टाइम हम बर्बाद नहीं करेंगे. The laws governing the structural characteristic of the phyllosilicates are Goldschmidt's law 1 and law 2. Both of these are very important. So law 1 tells in ionic crystalline compound, isomorphous replacement of one cation by another without incurring any change in order of crystal pattern is permitted, provided that radius of cation replaced and cation substituting agree within 10 to 15%. ये वैल्यू याद रखना है. इसका मतलब क्या है? आइसोमॉर्फस सब्स्टिट्यूशन जब होगा वो तभी होगा जब दोनों कैटायन का रेडियस एग्रीज विद इन 10 to 15%. 10 to 15% से ज्यादा अगर उन दोनों का डिफरेंस है, देयर विल बी नो आइसोमॉर्फस सब्स्टिट्यूशन. दिस इज लॉ नंबर 1 एंड लॉ नंबर 2 इज also called radius ratio law. This is also very very important. This word you should remember. JRF का क्वेश्चन खोलोगे, पहला क्वेश्चन में ये दिखेगा. So it is the number of anions that can be so accommodated around cation. It depends on ratio of radius of central cation to that of the surrounding anions. और यानी कि एक central cation है, उसके surrounding में anions है. So number of anions that can be accommodated, ये number कितना होगा? That will be defined by radius of the cation divided by radius of the anion. That number will decide कि इसके side में कितना anions बैठेगा. And that is why it is also called radius ratio law, because it depends on ratio of the cation by ratio of the anion. All right. So this is again from ISSS. This is ratio of radius decides coordination number, and coordination number decides shape of crystal. Very good. You are absolutely correct. So the principal structural groups, this is also from our beloved new ISSS. So number 1 is kaolinite serpentine group. Actually there are 5 main structural groups. This photo I have specifically taken because it is in new ISSS. उसमें बोल रहा है 5. All right, उसमें बोल रहा है 5. But if you see in treatise and old ISSS, उसमें बोलता है 4. So that's why I have taken this. है ना? So kaolinite serpentine group with 1:1 layer. Then pyrophyllite talc group with uncharged 2:1 layer. Then mica group with charged 2:1 layer. Then smectite vermiculite group, and finally chloride group. There are 5 types. I think you all know that exam is just less than 1 month away. So अभी इसमें ज़्यादा बातचीत करने का कोई ज़रूरत नहीं है. So structural principle, we will just come to that. On the basis of number of arrangement and silica and ammonia sheets, that's what I was telling. दो जगह में 2 है, उधर 5 है, इधर you can see 4 है, 4 है. So यहाँ पे 4 क्या बोल रहा है? 1:1 type, 2:1 expanding, 2:1 non-expanding, 2:1:1. है ना? तो एग्जाम में अगर आया तो देखना कहाँ से क्वेश्चन आ रहा है, what they are wanting. So 1:1 में भी dioctahedral है, trioctahedral है. All these examples are very very important. That's why I have put it in this PDF. If you read this PDF, you will get these examples in one place and it will be very good for you, right? Now the basic structure में तो अभी बोलने का कुछ नहीं है. Structure लेके हम इतना चर्चा किया. So 2 sheets of each crystal unit of kaolinite are held together by oxygen atoms which are mutually shared by silicon and aluminum atoms. Just as we told, tetrahedral अभी और मैं draw नहीं कर सकता. ये tetrahedral sheet है, इसके साथ octahedral sheet है. This layer is the mutually shared oxygen atoms. वही इसमें लिखा है. Then this statement is very 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 important. All of you know this. Still I will again emphasize, these units are held together very rigidly by strong hydrogen bonding. It is electrically neutral mineral, and for this hydrogen bonding also we all know उसका expansion नहीं होता, उसके अंदर water नहीं घुस सकता, उसके अंदर anions नहीं घुस सकता. All right, उसका isomorphous substitution भी नहीं होता. The basal spacing of kaolinite is 7.2 angstrom. Kaolinite crystals are hexagonal with clear-cut edges. All these are given in a table also in treatise. I think all of you know. MgOH2, very good. Kaolinite is abundant in more weathered soils such as altisol and oxysol. This line is also very important. It is a question-worthy line. Kaolinite से मैं old ISSS पढ़ा, मैं new ISSS पढ़ा, उसमें से मुझे इतना ही लगा which is exam worthy. बाकी उसमें बहुत सारा चीज लिखा है, तुम चाहो तो पढ़ सकते हो, but that will be of minor importance. This is our beloved kaolinite. As I was telling, this again, this layer का बात हो रहा था. This layer is the common layer between both octahedral and tetrahedral sheet. और यहाँ पे जो ये दिख रहा है, this is the hydrogen bonding. अब ये hydrogen bonding कैसे होता है? Here you can see all these are OH groups. तो OH groups में जो H है, that H is del plus and O is del minus. इसका मतलब क्या है? पोलैरिटी डेवलप करता है. O और H जब बॉन्ड बनाता है, O is highly electronegative, whereas hydrogen is electropositive. इलेक्ट्रोनेगेटिव का मतलब क्या है? कोवैलेंट बॉन्ड में जो इलेक्ट्रॉन है उसको अपनी तरफ खींचने का ताकत, दैट पावर ऑफ खींचना. सो ये जो इलेक्ट्रॉन पेयर है उसको अपनी तरफ खींच लेता है. अब अपनी तरफ खींच लेगा तो क्या होगा? देयर विल बी डेवलपमेंट ऑफ अ माइन्यूट नेगेटिव चार्ज ऑन ऑक्सीजन, और यहां से इलेक्ट्रॉन दूर जा रहा है, सो देयर इज अ डेवलपमेंट ऑफ माइन्यूट पॉजिटिव चार्ज. सो ये OH ग्रुप का जो H प्लस का पॉजिटिव चार्ज है, और यहाँ पे जो दिस इज ऑक्सीजन, ऑक्सीजन का जो नेगेटिव चार्ज है, this will form a bonding. This is called hydrogen bonding, as we all know, right? This is called hydrogen bonding. So because of this strong hydrogen bonding, ये जो interlayer space देख रहे हो, in this interlayer space nothing can enter because it will not expand only. All right? And जो अभी मैं बोल रहा था, A dimension, B dimension, here you can clearly see C dimension में stacking होता है. Remember, हाँ, C dimension में stacking होता है. यहाँ पे और कुछ अच्छा पॉइंट लिखा हुआ है. This I will emphasize. Please remember the formula of kaolinite, because kaolinite का बैठ के एग्जाम हॉल में बैठ के you cannot devise out the formula. You cannot draw the structure और फिर formula तुम निकाल नहीं सकते, उतना टाइम नहीं रहेगा. That you can do in your same exam, but not in JRF, SRF और ASRB, ARS कुछ में नहीं कर सकते. So you have to remember, right? Formula अगर यहाँ से देखो तो it is very easy. It is very easy to figure out, but you don't have the time. So it will be Si4, Al4, O10, OH8. ये formula याद होना चाहिए. Kaolinite exhibit less plasticity, stickiness, cohesion, shrinkage and swelling, and also can hold less water than other clays. ये तो सबको पता है. This is nothing new. Because of this property, soils dominated by 1:1 clays are relatively easy to cultivate. ये याद रखना. Easy to cultivate for agriculture. हाँ? Easy to cultivate for agriculture and with proper nutrient management can be quite productive. All these are lines of ICCS. I know all of you know. इतना बार तो पढ़ ही चुके होंगे. Kaolinite containing soils are well suited for use in roadbeds and building foundations. The non-expanding kaolinite clay is useful for making bricks and cements. This is also very important. हो गया. अब kaolin का जो kaolin clay होता है उसके बारे में we'll see बाद में और डिस्कस होगा. So kaolinite का ग्रुप का एक और बहुत इंपॉर्टेंट मिनरल है halloysite, है ना? Halloysite. So I have specifically put these points for you. Halloysite also has structure similar to kaolinite, except that layer of water molecule is hydrogen bonded between the layers. मतलब it is exactly similar to that of kaolinite, but in this layer जो hydrogen bonded layer है उसमें there is a water layer. एग्री केमिकल्स मैराथन मैं ही कराऊंगा भाई, थोड़ा रुक जाओ, पहले केमिस्ट्री कर लो. केमिस्ट्री का जरूरत नहीं है क्या फिर? So halloysite has also the structure similar, but it has a layer of water molecule hydrogen bonded between 1:1 silicate layers. All right. The basal spacing is, you can see it is more than kaolinites. It is 10.25. Its shape appears as elongated tubules. This is also important. The shape is elongated tubules. Fully hydrated halloysite is also called endelite. This is also an information for you. Probably नहीं आएगा, आ भी सकता है, तो याद रख लो. The specific surface area is approximately इतना. The X-ray diffraction peak will disappear after hitting kaolinite to 500 to 550. इसका अभी तुमको जरूरत नहीं है. This is from XRD. People who are giving SRF, वो अगर कोई देख रहा है, so that will be important for them. क्लोराइट और kaolinite दोनों का पीक सेम आता है. उस दोनों में डिफरेंशिएट करने के लिए we have to heat them up to 500 to 550 डिग्री सेल्सियस. 500 to 550 डिग्री सेल्सियस में kaolinite ग्रुप का क्या होता है? इट डिकम्पोजेस. उतना हीट वो नहीं ले पाता है, बट क्लोराइट डज नॉट. सो 550 डिग्री के बाद भी अगर सेम पीक आ रहा है, दैट मींस दैट इज अ क्लोराइट. और अगर पीक नहीं आ रहा है, पीक चला गया, मतलब सॉइल में kaolinite था. दिस इज आइडेंटिफिकेशन. दिस इज XRD, not that required for you. So coming to the 2:1 minerals, we all know talc and pyrophyllite at the prototypes. प्रोटोटाइप मिनरल्स, यानी कि these are the ideal minerals जिसको हम देखते हैं. टैल्क हैज Mg इन ऑक्टाहेड्रल साइट, इसको याद रखना इजी है. टैल्क के साथ ट्राइऑक्टाहेड्रल याद रखना, टी एक साथ मिला दो, टी के साथ टी मिलेगा तो ट्राइऑक्टाहेड्रल होगा, तो मैग्नीशियम रहेगा. whereas pyrophyllite has aluminium and is dioctahedral. So talc अगर trioctahedral है तो वो dioctahedral है, सीधी सी बात है. The charge is balanced within 2:1 layer, making it electrically neutral. These two, talc and pyrophyllite, are totally electrically neutral. याद रखना, न्यू IEEE में बहुत अच्छे से दिया हुआ है, उधर पढ़ लेना. The adjacent 2:1 layers are held together by very weak van der Waals force. यहाँ पे कुछ हाइड्रोजन बॉन्डिंग नहीं है, कुछ नहीं है. So it is only by weak van der Waals force when found in soil. इसके वजह से क्या होता है, since these are very weak interlayer bonding है, तो very easily the layers slip over each other. इसीलिए if you see talc हम लोग तो daily use करते हैं, the powder we use, that is also talc powder, and also if you write with chalk, that chalk is also talc only. Talc होता है ना इसमें, yes. So if you take that talcum powder in your hand and you do it like this, you will see your hand is slipping. Your hand is slipping. So that slipping is because ये जो एक लेयर के ऊपर एक दूसरा लेयर है, उस दोनों में बॉन्डिंग इतना कम है कि it very easily slips over each other. All right. So this okay. So now coming to micas. In case of mica, 1/4 of tetrahedral site is occupied by Al. इसको याद रखना है. 1/4 of tetrahedral site is occupied by Al. That is, this is also a case of isomorphous substitution. जहाँ पे सिलिकॉन होना चाहिए था, वहाँ पे एल्यूमिनियम आ रहा है. And this substitution causes an excess of 1 negative charge per formula. सही बात है. 1/4 of tetrahedral is filled with एक ion which is 1 less positive charge. So it results in 1 negative charge per formula unit. This excess negative charge is balanced by potassium. That is why mica has very high potassium content that occupy the interlayer sides between two adjacent 2:1 layers. The K plus ions between unit layers are not available for exchange. क्यों? ये मैं बहुत देर तक already समझा दिया. Because of ditrigonal cavity, which is very similar in diameter with the unhydrated potassium ion, तो उसको ऐसे पकड़ लेता है, it does not allow to let it go. That is why this is not available for exchange. Moving on, these are just simple information for you. इसमें ज़्यादा कुछ बोलने लायक तो नहीं है. These are just very simple informations for you. Still देख लो. Biotite and phlogopite are trioctahedral. इसमें समझाने का कुछ नहीं है. Already I have told many times why biotite is trioctahedral and why biotite is more weatherable than muscovite. हम ये बोल चुके हैं. Phlogopite containing Mg in the octahedral site, while biotite contains Mg and Fe both. We know biotite is ferromagnesian. That is why the color of biotite is black. सब कुछ एक साथ रिलेट होना चाहिए. You have to correlate everything and you will be good to go. Muscovite is dioctahedral and contains aluminium. That is why muscovite is white in color, है ना? Mica and chlorite is a primary mineral. This is very important. बाकी जितना भी हम clay पढ़ते हैं, clay minerals पढ़ते हैं, kaolinite, smectite, everything is secondary. Mica and chlorite comes under primary mineral. Mica's weather to other minerals, you know, new IEEE में ये भी है, mica weathering. Particularly to vermiculite and smectite, and K plus ion is released during weathering. Muscovite micas are more resistant to weathering. This I have already explained in detail. All right. This is a ideal photo of Shayanta. Welcome, sir. This is the ideal photo of muscovite that is having this structure. You can read this. देख लेना, इसमें नया कुछ है नहीं. Here you can see this is a dioctahedral. That is, it contains aluminium because this place is empty. Then coming to vermiculite, vermiculite has a layer charge of 1.2 to 1.8. This also one table is there in new ISSS. Please, please, please read that. That is very important. उसमें जो layer charge per unit formula weight है, per unit cell है, you have to remember all the charges. You can make a triangle like this, and you can remember एक एक ऐसा line करके. You can remember this part will be mica, then this will be vermiculite, this will be smectite, and finally this will be pyrophyllite and talc. All right, thank you, Sujit. So you please, I would suggest, make a triangle like this. Yes, mica has 0.9 to 1, it will come in this. Mica has 1.8 to 2 per unit cell. So you can make a triangle like this and you can remember easily, and in this side you can put substitution in the tetrahedral layer, in this side you can put substitution in the octahedral layer, and you can read that table. That mug, please comment in English. So this is the vermiculite has a layer charge of 1.2 to 1.8 equivalent per unit cell, which is neutralized by 0.9 mole of hydrated Mg2 plus ion. We all know vermiculite has Mg. Magnesium has exchangeable cations in interlayer. The high charge per formula unit gives vermiculite the maximum CEC. यहाँ से यही important है और कुछ आएगा नहीं. So maximum CEC, and causes them to have high affinity for weakly hydrated cations such as K+, NH4+, and CS+. The basal spacing is 10 to 15 angstrom. This is also a question worthy. Yes, Vipin, very good. You have to remember that. This basal spacing is also very important. Vermiculites in soils are believed to be formed almost exclusively from weathering of mica and chlorite. Although its layer charge is more than mica, all of its layer charge is expressed as CEC. That is why vermiculite has the maximum CEC. इसमें I don't think और कुछ doubt होना चाहिए. अगर है भी तो you can read ISSS and clear your doubts, because यहाँ पे समझाने का और कुछ है नहीं. So now coming to the smectite. Yes, as Vipin has wrote, smectite का layer charge is 0.4 to 1.2. Exactly, perfect, you have written. The smectite group contains several minerals such as montmorillonite, badellite, nontronite, and saponite. These are having flake-like crystals. Smectite crystal range in the diameter from this. In montmorillonite, this is important, this line is important, you can read. In badellite is not that important. The basal spacing of montmorillonite varies from 9.6 to 18 angstrom. Yesterday, someone was asking कि C spacing किसका ज़्यादा है, vermiculite or montmorillonite. So I think you are getting your answer, because 18 angstrom here you can see, whereas vermiculite only can go up to 15, and this is common sense only. Mostly we will take it as 14 angstrom depending on the moisture. Depending on the moisture, that is under quotes. Why? Because जो इंटरलेयर जो स्पेस है, ये इंटरलेयर स्पेस में अगर मॉइस्चर घुसा, if there is moisture, it will be more. In that case, sir, what is bentonite? Bentonite is a 2:1 smectitic mineral. It is used in swimming pools, you know. You please tell in IRI to make a swimming pool and we will apply bentonite there, huh? Yes, nontronite is also known as iron bearing montmorillonite. So smectite dominates in clays of shrink swell soils. This is also very important. This statement you should know. And all of the bentonite. All of the layer charge appears as CEC and is neutralized by calcium and sodium as exchangeable cations in its hydrated form present in the interlayer. The lower layer charge allows moisture absorption in interlayer and expansion to very high C spacing. This is also very important. The internal surface area thus exceeds the external surface area. Very good. The chloride group, we have come to the last group. This part is very boring. I also know there is nothing to explain, but yeah, you can read. Interlayer is occupied by Mg dominated trioctahedral. Someone was writing in the live chat, I saw. Someone was writing Mg3 OG6. This can also be written as है ना? This is the formula of brucite, we all know. The brucite sheet has a positive charge developed by substitution of Al3 plus for Mg2 plus. The positive charge is neutralized by negative charge in tetrahedral, octahedral sheet and thus gets attached together. Specific surface area varies from this to this and characteristics D-spacing is this much, which does not shift or collapse on treatment with glycerol or heating to 500 degrees Celsius, as I was telling. That is how we can differentiate between chlorite and kaolinite. That is how we can differentiate between chlorite and kaolinite using XRD, and thus this mineral has practically zero cation exchange capacity because all the cation exchange capacity is neutralized by the brucite sheet. All right. So these are the different properties that have been listed for all of you. Here you can see. So in this, the shape, the C-axis spacing and the CEC is very important. All this will have, these are all question worthy and question might come. All right. So we have come to the amorphous soil constituents, the amorphous parts of soil that we all know. Paracrystalline are the having long range order in only 2 dimensions. I think all of you know this, you might have read the new ISSS, there it is written. Only with or without defects. The allophane, these are paracrystalline aluminosilicate minerals without defects, they produce no X-ray diffraction effect, whereas in imogolite you can see it has broad X-ray diffraction peak. All right. So this is the basic difference between allophane and imogolite. From allophane and imogolite, there is one question also in the later part. We will see that whether you can manage to do it or not. So these are the structures. These you can read from the PPT or also you can read from the book. There is nothing to explain here. So finally, we are coming to the real chemistry, that is ion exchange in soil. Now we will see what is ion exchange. Ion exchange in soil system refers to exchange of equivalent amounts of ions. This equivalent is very, very important. You have to remember equivalent. All the exchange reactions happen in equivalent only. This equivalent is nothing but, thank you Shandipta, thank you. This equivalent concept is a basic concept of class 11 chemistry, all of you know. So any exchange of ions takes place in equivalence only. Any chemical reaction takes place in equivalent only. It will not take place if it is not in equivalent concentration. All right. Between two phases in equilibrium, and it is a reversible process. So all these are the keywords which you should remember, the JRF aspirants especially. Cation-cation exchange, anion-anion exchange. The experimental evidence of cation exchange was provided around 1850 by Thomson, followed by J. Thomas Way. So here will be an interesting story for you that I also learned very recently in IRI. So this Thomson, this gentleman, he was not a scientist, you know. Thomson was not a scientist, he was a farmer. He was a farmer, and J. Thomas Way was a soil chemist. He was working in Rothamsted Experiment Station. So Thomson was the first guy who reported the cation exchange property, and then he contacted and told it to J. Thomas Way, and they together then did the experiment, and the ion exchange or the cation exchange came into being. So how they did the experiment, that is in ISSS, I think you have seen, or I will tell you. They took a soil column, and in that they have applied heavy dosage of ammonium sulfate. Ammonium ions यहाँ से apply किया, and when they collected the leachate in the below, they could find Ca2 plus ions. All right. So they, from this they concluded that in the soil column there must have some exchange must have happened, for which the calcium and other ions are coming in the. So cation exchange capacity, what is cation exchange capacity? This is the basic for every student out there. It is the capacity of solid to adsorb and exchange. All right, adsorb and exchange cations, it is called cation exchange capacity. In other words, it is the sum total of exchangeable cations that can be adsorbed by a soil colloidal surface. So it is the sum total of exchangeable cation that can be adsorbed. Total quantity, it can also be defined as This is also a very important definition. This also you should remember. It is the total quantity of negative surface charge on the inorganic or organic colloid which is available to attract cations. So cation exchange capacity can be expressed in the way of cations, कितना cations उसमें जुड़ा हुआ है और कितना negative charge colloid के पास है which is available to attract the cations. All right. So this is very important. Units are very, very important. SI system unit which is used presently, that is centimole positive charge per kg of soil and milli equivalent per 100 gram of soil in the classical unit. Here P plus denotes proton or positive charge. So इन दोनों में कभी अगर conversion आया, so the conversion is not at all hard. I think all of you know. What is the conversion factor? Can anyone tell me? What is the conversion factor between centimole positive charge per kg and milli equivalent per 100 gram of soil? Anyone, please? Can anyone tell what is the conversion factor? 1. Wow, Tarun sir. Very nice. So yeah, this is a very simple one. We all know this will be equal. So you don't have to worry about the conversion. But if you are writing, like if it is in a subjective exam, so remember the unit. You have to write the answer in the unit that is given in the question only. Otherwise, you have to convert, and that conversion is same. That is equal. The conversion factor is 1. Similarly, anion exchange capacity of soil colloid can also be defined in the exact same way. It is expressed as units of centimole electron per kg of soil. Centimole electron per kg of soil. All right. Moving on. Famous physical chemist. This is written in new ISSS. New ISSS का soil chemistry and mineralogy chapter का first quote you will see. She Marshall has emphasized that CEC is second most important in nature after photosynthesis. CEC is next to photosynthesis. The question that will come from here is, who told CEC is next to photosynthesis? And the answer would be C.E. Marshall. This is a very important question and might come. All right, this is a very important question and might come. And since this is not subjective, they will not ask why, but you should also know why it is called so. And this part has been exclusively taken from T.D. Vishwas, you know, the classic old textbook. There it is written. You cannot find this in new ISSS, new or old, किसी में भी नहीं मिलेगा. So ECEC, what is ECEC? ECEC is the effective cation exchange capacity. ECEC is the effective cation exchange capacity, which is the sum of exchangeable bases as extracted by 1 molar neutral normal ammonium acetate at 7 and 1 molar KCl extractable Al3+. So it is the CEC that we got from this method and the extractable aluminium, that is called ECEC. This also might come in exam, so please be careful. Moving on, what are the factors that affect cation exchange capacity? These are very easy. We will just move past these. Effect of clay minerals. Generally 2:1 minerals have more CEC compared to 1:1 minerals. This table all of you know. Effect of organic matter. We know organic matter has lots of functional groups. Those functional groups will result in lots of negative charges in the soil, and this negative charge is nothing but, these negative charges are nothing but, this is the cation exchange capacity. So organic matter jitna dalenge, soils having large amount of organic matter exhibits definitely more CEC. Generally with increase in soil pH, CEC increases. Why? This we will see in the origin of charge. In most soil laboratories, CEC is determined by extraction with 1 normal neutral normal ammonium acetate. Neutral normal का मतलब है 1 normal at pH 7. This is also very important. Moving on. For anion exchange capacity also it is the same. Nothing new to tell here. Factors affecting is also the same. Soil pH. With increasing soil pH, anion exchange capacity decreases, because here you can see in case of CEC it increases. The anion exchange capacity is nothing but total stark opposite of that. So ये अगर बढ़ता है तो ये घटता है. And valency of ions, anion exchange capacity increases with valency of the anion but decreases with increasing valence of the cation. All right. This table has also been taken from treatise. So please be very thorough with this. This is the ratio of CECs to AEC. Here you can see kaolinite has less than 1. Less than 1 indicates what? Less than 1 indicates AEC is greater than CEC for kaolinite. And for this you can see it is more than 1. That means CEC is greater. All right. Here especially for you, I have taken this thing also. You should know what is negative adsorption. It is the repulsion of anions by the negatively charged sites. It leads to a local deficit of anion near clay particle in comparison with the equilibrium solution. This deficit has been termed as negative adsorption. As almost all the soil found in nature possess net negative charge, so negative adsorption or anion exclusion, it is also called anion exclusion. It is exhibited to a certain extent by all soils. So इसका मतलब क्या है? We will understand it very simply. This is a soil colloid which is negatively charged. So इसके पास में जो रहेगा those are cations, but जो anions रहेगा due to repulsion it will be far away. It will be far away and this is the boundary layer. इसके बाद this is the bulk solution. This is the bulk solution. So ये boundary layer में आके all the anions will form a kind of a layer, kind of a hypothetical layer. So we are taking it as an indirect adsorption and this is called negative adsorption or anion exclusion. जिसका वजह है this, जिसका वजह है repulsion. Repulsion is the reason. All right. So we have come to theories of ion exchange. Theories of ion exchange is my most favorite part of chemistry. So theories of ion exchange में सबसे पहले आता है adsorption isotherm. What is adsorption isotherm? Adsorption isotherm क्या है ना? In any adsorption experiment, when we report the data in the form of a graph. ठीक है? We report the data in the form of a graph. अब इस ग्राफ में क्या होता है? ग्राफ में this is y axis, this is x axis. This y-axis is the plotting of amount of adsorbate adsorbed per unit mass of adsorbent and this is the equilibrium concentration of the adsorbate. इसका क्या मतलब है? Might have been a bit difficult for you. I will tell you. Adsorption is a surface phenomenon. We all know that, right? So adsorption मान लो यहाँ पे हो रहा है. This is adsorption. जिसके ऊपर adsorption हो रहा है, that is the adsorbent. बेंट है ना, बेंट BENT और जिसका एड्सॉर्प्शन हो रहा है दैट इज एड्सॉर्बेट. सो दिस अमाउंट ऑफ एड्सॉर्बेट पर यूनिट मास ऑफ दिस एड्सॉर्बेंट, दिस इज टेकन इन द वाई एक्सिस एंड द इक्विलिब्रियम कॉन्सेंट्रेशन ऑफ द एड्सॉर्बेट, ये एड्सॉर्बेट का इक्विलिब्रियम कॉन्सेंट्रेशन क्या है इन द नेचर, दैट इज टेकन इन द एक्स एक्सिस एंड दिस graph is called adsorption isotherm. अब isotherm का क्या मतलब है? This report is only made in constant temperature, equal temperature, because temperature affects the process of adsorption. Temperature affects the process of adsorption. Temperature अगर ज्यादा होगा कम होगा उस हिसाब से adsorption process will उसका बदल होगा. That's the reason this graph is expressed in constant temperature. All right. So this is the reason it is called adsorption isotherm. Isotherm का मतलब होता है iso is equal, therm is temperature. In equal temperature, we report the data in equal temperature. All right. So the adsorption process deals with adsorption of molecules from soil solution on surface of soil solid. हमारा soil science में adsorption पढ़ने का यही मकसद है. There is no other मकसद. The material adsorbed is adsorbate and the material on which adsorption occurs is adsorbent. The result have been fitted to several standard adsorption isotherms, जिनमें से notable है Langmuir, Freundlich and Temkin and then finally BET. All these isotherms you have to remember the year. जितना भी खराब लगे you have to remember the year. Langmuir 1918. All right. Then Freundlich 1926 and then BET is 1938. it is written here, but ये year भी याद रहना चाहिए. These years are very important. So what is Langmuir adsorption adsorption isotherm? We all know that it is the basic theory. यहाँ से बहुत सारे question आता है, so please be very attentive. Please be very attentive. This is the basic theory of adsorption of gases on solids, explained by Langmuir, and it is based on the following assumption. These 4 assumptions are extremely important. I would suggest you to make a list of all the assumptions. मैं पहले भी बोल चुका हूँ, जितना भी laws है, Stokes law, Darcy's law, double layer theory, then these adsorption isotherms, सबका जितना भी assumptions है उसको एक जगह में लिख लो, एग्जाम के पहले उसको पढ़ के चले जाओ. Trust me, at least 7 to 8 question, maybe 5 to 7 question definitely you are going to get. All right, so इसका जो assumption है, assumption क्या बोल रहा है? Surface of solid is made up of different adsorption site, each of which can absorb exactly one gas molecule. यहाँ का keyword यही है, adsorption site होता है and each can absorb only one gas molecule. Second क्या है? Second is very easy. Rate of adsorption is proportional to the number of adsorption site and pressure of gas. The rate of desorption is directly proportional to the number of occupied site. This is very easy. This is very easy because here what he is telling, the adsorption site होता है ना? So adsorption site मान लेते हैं ऐसा ऐसा होता है, and these are the gas molecules. So rate of adsorption is this way, rate of desorption is this way. Rate of adsorption will definitely depend on the pressure of the gas, कितना molecule है, कितना pressure डाल रहा है, and also the number of adsorption site, कितना adsorption site है, उस हिसाब से it will go. And the rate of desorption will depend on number of occupied site. This is also extremely common sense. जितना site occupied है, उतना ही desorption हो सकता है, उससे ज़्यादा desorption तो हो नहीं सकता, है ना? So these are the 2 assumptions. Then third assumption is all adsorption sites are identical for their affinity, and the fourth is presence of gas molecule on one side does not affect the properties of neighboring site. मतलब यहाँ पे जो adsorption हो रहा है, that has no effect on adsorption on the neighboring site. This is the these are the 4 assumptions. So this line has questions. इस line से PYQ में at least 2 to 3 questions I have seen. Langmuir adsorption isotherm refers to gaseous adsorption on non-ionic solid, whereas in soil it is essentially an ionic process. So that's where Langmuir adsorption isotherm fails. Also ये assumption में भी अगर देखोगे, so it fails in multiple types, in multiple ways. How? Because this from C and D, all adsorption sites are identical in affinity. This is not possible in the soil because soil we know is a polyfunctional exchanger. It has lots of functional groups, it has lots of compounds, so it can never have all the same identical affinity for adsorption. That is one. And second one is presence of adsorption in one site does not affect properties of neighboring site. This is also never possible in soil because of interaction. There is cationic interaction, there is antagonistic interaction, there is competition. If calcium is going, it is competing with Mg. If Mg is going, it is competing with K. So there is definitely a influence of one ion on the neighboring site. So this is also not possible. C and D fails Langmuir isotherm in soil, but still here we'll see use of Langmuir equation provides a measure of adsorption maximum. This is very important. This is a very important question. Adsorption maximum. Yes, use of Langmuir equation provides a measure of the adsorption maximum. Langmuir adsorption isotherm describes the nutrient retention process in soil, especially at higher adsorbate concentrations. So at higher adsorbate concentrations, it somewhat fits, but majorly the assumptions do not fit. Normally, the Langmuir equation is not used to calculate the surface area of soil. This part of this PPT, every word is a question. I'm telling you, every word is a question. Monolayer adsorption, that is a question. Then again, the nutrient retention of phosphorus at high concentration, that is a question. And again, it is not used to calculate the surface area, that is also a question, because it does not define total adsorption process, but covers only a certain fraction. All right, this is also a question. Now coming to Freundlich, you can see 1918 से हम 1926 में आ गए, so it is almost 8 years later. 8 years later क्या हो रहा है? This is one of the most widely used empirical adsorption equations. Can anyone tell me what is the empirical equation? Anyone? Just 1 or 2 words. Can you tell me what is empirical? Empirical equation का मतलब क्या है? I know all of you have read ISSS and all of you have read this definition multiple number of times. Freundlich is originally an empirical equation, later on devised on rigorous mathematical models. That definition I have also read maybe 100 times. So can anyone tell me what is empirical, please? What is an empirical equation? Empirical का मतलब क्या है? I cannot see any comments. That is very sad. No one is writing. That is actually very sad. So I can see almost 11 people are there. Anyhow, empirical का मतलब होता है, empirical is see, only fractional value, not the exact value. At least you are trying. That is very good. But no, Aishwarya, you are wrong. That is not the correct answer. Empirical का मतलब क्या है? I will tell you. Empirical, see, whenever there is a theory, क्या होता है? पहले theory दिया जाता है, उसका assumption दिया जाता है. First you give the theory, then you give the assumptions, then you do the experiment according to that theory, and then you tell कि हाँ, this theory is this much effective in telling this phenomenon, whatever is happening. Empirical का मतलब है इसमें कोई theory नहीं है. It was directly used in an experiment. Then that experimental data was collected and then that data was fit in different equations. Different equation में वो data fit करते 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 they got this equation. So that is empirical. मतलब first they did the experiment, they collected the data. From that data they are like, it is like the reverse process. हम लोग theory से experiment में जाते, theory से practical. This is practical से theory. पहले we did the practical. There we did all the experiment, we got the data. Then after arranging that data, we are trying to fit it in an equation. That equation we are describing here. That is why it's called a empirical equation. है ना? That is why इसका कोई assumption नहीं है, इसका कोई theory नहीं है, इसका कोई theory ही नहीं है. There is nothing. No assumption also. Why? This is the reason. So this is one of the most widely used because ये बहुत easy है, इसका calculation बहुत easy है. All of you will do that when you come to your MSc. We also have done that. To describe experimental data on adsorption of ionic or molecular species in soil, this is very important, याद रखना. However, it does not predict any adsorption maximum. This is the problem and this is the difference. यहाँ पे एक ही पेज में difference is clear, you can see. Adsorption maximum you can calculate from Langmuir, but in case of Freundlich you cannot. It cannot predict the adsorption maximum. It is expressed by the equation. ये equation तो तुम सबको पता है. इसका क्या क्या मीनिंग है, दैट इज ऑल्सो यू नो, x इज द अमाउंट एब्जॉर्ब पर यूनिट मास, c इज इक्विलिब्रियम कॉन्सेंट्रेशन, जो मैं बोल रहा था. तो इसका जो ग्राफ होगा, दैट ग्राफ विल बी लाइक दिस. सिंस यू कैन सी दिस इज गोइंग लाइक दिस विथ इंक्रीजिंग कॉन्सेंट्रेशन, इट विल बिकम फ्लैट एंड इट विल गो ऑन. जितना भी कॉन्सेंट्रेशन बढ़ाते जाओ, इट विल गो ऑन लाइक दैट. दैट इज व्हाई इसका कोई एब्जॉर्प्शन मैक्सिमम देने का it has no power. Adsorption maximum का मतलब क्या है? The highest point of adsorption. उसके बाद से अगर concentration बढ़ेगा भी तो it will go down, it will go this. But this has no highest point because it will go on indefinitely. It will go on indefinitely with increase in equilibrium concentration, जो कि असल में possible नहीं है because once the whole adsorption is done, multiple layers is also done. उसके बाद there will be no adsorption at a point. But that is the reason why we cannot get adsorption maximum from Freundlich. Okay, coming to BET. BET में ज़्यादा कुछ पढ़ना नहीं है. BET is very tough. You have to remember only the keywords. So the theory of Brunner, Emmett and Taylor, you have to remember the names of the scientists. It extends Langmuir derivation. This is important. It extends Langmuir derivation to obtain an equation for multi-layer adsorption. दिस इज द मोस्ट इंपॉर्टेंट, बीईटी के साथ मल्टी लेयर एकदम, it should be in your tongue, it should be in your lips. जब भी आए you just tell. Advantages, these three advantages are very important. It describes multi-layer adsorption, जो इसके पहले कोई कर नहीं पाया था. It yields volume of gas required for formation of monolayer. It can be used to calculate the surface area. यही तीन लाइन से, these three statements are the three questions. These three lines you should remember, and also this note is also another question. BET equation is most useful between the relative pressure of 0.05 to 0.45. This is also a very important question. And finally, Temkin, this is not there in the old ISSS, so many of you might have missed it. That's why I have taken it for you. This is in the new ISSS. Temkin equation, it assumes bonding energy of adsorption decreases linearly with increasing surface coverage. In this, the keyword is linearly. This linearly is the keyword. अगर bonding energy linearly decrease कर रहा है, that is the Temkin. अगर linearly decrease नहीं कर रहा है, then that is Freundlich. All right, so we are done with the adsorption isotherms. Now, if you are liking the session, please drop some thumbs up or something, because since we are not interacting at times, it might get very boring. So please let me know you are there and you are enjoying, or you are liking, whatever you are not liking. If there is any doubt, anything that you want me to change, anything that you want me to tell again, you can ask. Anything related to soil chemistry, you can ask. So, coming to the base saturation, again we are coming on the easy part. Adsorption isotherm was the hard part. So the ratio of exchangeable basic cations. Did all of you understand the adsorption isotherms, or you need some other explanations? Please tell. We are almost on the 1.5 hour mark. Please, can anyone give any feedback? Anyhow, so yes, Nikhila, yes, it's very good to see that you are understanding. If you have any doubt, anything, you can tell me always. I will try my best to make you understand it in a very easy way. All right, so base saturation, this I should not teach you, this you guys should tell me. Isme kuch nahi hai, nothing is there. Ratio of exchangeable basic cations on solid surface and CEC is termed as relative base saturation. If it is expressed on percentage, it is called percentage base saturation or BSP, base saturation percentage. In general, 1:1. This statement is very important, है ना? This statement is very important. इसको याद रखना. 1:1 clay can supply nutrient cations to plants at a much lower percent base saturation. Much lower percent base saturation में 1:1, है ना? This you might have some problem in understanding. This you should remember. Base saturation increases with increase in soil pH. How? This also we will discuss later. At 7% base saturation, about 80, and each unit decrease in pH, base saturation decreases by 20%. This line is from treatise. I think all of you have read that. There is nothing to do. This is the formula of percentage base saturation, where we will take the basic cations divided by CEC into 100 will be the percentage. Up, coming to this statement. Why is this statement? बोल रहा है 1:1 clays can supply nutrient cations to plants at a much lower percent base saturation than the soils in 2:1 clays. How? Let us assume 1:1 clay, 2:1 clay, है ना? अब दोनों का बेस सैचुरेशन परसेंटेज हम लोग सेम मान लेते हैं. से this is also 50%, this is also 50%. सॉरी, बेस सैचुरेशन कैसे 50 मान सकते, क्या नहीं मान सकते? एक्सटेंट ऑफ बेसिक कैटन, लाइक दिस पार्ट, दिस न्यूमरेटर, उसको हम लोग सेम मान लेते, से यू से सम वैल्यू दैट इज 80, दिस इज आल्सो 80, दिस इज द न्यूमरेटर. सो न्यूमरेटर उसका यूनिट होगा मिली इक्विवेलेंट पर 100 ग्राम, इसका भी यूनिट होगा मिली इक्विवेलेंट पर 100 ग्राम. ठीक है, these are the basic cations that is needed by the plants. अब इन दोनों में से हु हैज द हायर कैपेसिटी टू डोनेट। अब आते हैं इसका डिनोमिनेटर में, डिनोमिनेटर इज सीईसी, सो सीईसी वी नो सीईसी ऑफ 1:1 इज ऑलवेज लेस देन 2:1, तो इसका सीईसी कितना होगा, इसका सीईसी मान लेते हैं से सम रैंडम वैल्यू, इसका सीईसी मान लेते हैं इफ दिस इज 100, इसका मान लेते हैं 80 ही मान लेते हैं, ऑल राइट। सो यू कैन सी आउट ऑफ 80 इसका अगर लोअर भी है, सो दिस BS will come as 1, this will come as less than 1। तो CEC में जितना भी बेस सैचुरेशन है, that the 1:1 clay is more ready to supply because उसका CEC कम है, उसको रिटेन करके रखने का क्षमता कम है ना। And this increase in soil pH we will understand in detail later, no problem। note for you, please note down, if base saturation percentage is more than 80, it indicates highly fertile soil. If it is 50 to 80, it indicates medium fertile soil, and if it is less than 50, it is the less fertile soil, all right। This is there in new ISSS, I have given this table just for your understanding, है ना। This will be very important for you, you should know। According to order, there are two types of solid, crystalline and amorphous, crystalline and amorphous। Or amorphous, so we already discussed, in crystalline there are 4 types of solid, I think all of you have read it from new ISSS, this part is very important। So covalent solid, ionic solid, molecular solid and metallic solid, here all the keywords you should remember, in the metallic you should see they are not localized and there is no directional carrier, so it can be readily twisted। no directional carrier का मतलब क्या है, कोवेलेंट बॉन्ड जब फॉर्म होता है और कोऑर्डिनेट कोवेलेंट बॉन्ड जब फॉर्म होता है, इट हैज अ स्पेसिफिक डायरेक्शन, डायरेक्शन का मतलब इलेक्ट्रॉन का एक डायरेक्शन है, बट इन केस ऑफ मेटालिक सॉलिड इट इज लाइक अ सी ऑफ इलेक्ट्रॉन है, उसके बीच में metal ions are interspersed, that is a metallic solid। that is why since it has no directional carrier, it can be readily twisted, and all those properties of metal that you read, malleability, ductility, all those things happens in metallic solids because of this, but in case of the other ones it is not that easy to bend। for molecular solid, you know, intermolecular bonds are due to dispersion force, van der Waals force, two neutral molecules are held together by instantaneous dipole। in case of ionic, you all know it is a electron fully दे देना, and covalent is electron एक ये देगा sharing होगा, ठीक। and this is also very important, this part actually यहाँ से ज्यादा क्वेश्चन आता नहीं है, but I would only make you focus on the important parts। so close packing दो तरह से होता है, you all know, hexagonal and cubic, HCP and CCP। in this you have to remember only two things, AB, ABC, all right। ABC is cubic and AB is hexagonal, they can ask this, AB type of packing is found in what and ABC is found in what। बाकी इसमें question is not that much, we can expect। now coming to 0-point charge, this is also a very important topic, so please I need some josh from you, everyone is sitting very quiet, at least comment something, कुछ भी लिख दो यार, I will make you understand it in a very good way as per my understanding, जितना easy करके हो सकता है, I will make you understand that। where is everyone? You have turned on the video and went somewhere, or what is the case, or are you feeling tired? अभी तो 2 घंटा भी नहीं हुआ। anion exchange capacity का ऑर्डर, anion exchange capacity का ऑर्डर कैवलिनाइट का सबसे ज्यादा होगा ना भाई, 1:1। व्हाट ऑर्डर आर यू, जिसका CC ज्यादा है उसका AC सबसे कम है, उसी हिसाब से ऑर्डर बना लो, just the opposite of CC order। anyhow, coming to ZPC, ZPC आने से पहले we will read what is origin of charge, like Darwin's book, Origin of Species. We will read here origin of charge. So origin of charge, all of you know. Please tell me what are the two processes? What are the two types of charge? You tell me. What are the two types of charge that we can find in colloids, clay colloids? Two types of charge. Please. What are the two types of charge that can be found? दोनों पी से स्टार्ट होता है, वो भी मैं लिख दिया. हाँ भाई, फ्रूट साइंस तुम बाद में आ सकते हो, अभी सॉइल में तो anyhow. Can anyone write what are the two types of charge? Please. Aishwarya, Shreyoshi, Vipin, Nikhila. Yes, 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 yes. Very good. Permanent and temporary. Temporary is a good word, but temporary का best ये है, it will be pH dependent. So this permanent charge is also called permanent structural charge, right? We all know that permanent structural charge, and this is the pH dependent charge. This permanent structural charge takes place because of isomorphous substitution. We all know that, right? इसमें तो और नया कुछ बोलने का है नहीं. It is because of isomorphous substitution. Isomorphous substitution में isomorphous substitution, isomorph means equal size. We already read in Goldsmith's law 1 that the radius of the two substituting cations should be within 10 to 15%, right? And also another rule is there, the valency, the difference of in valency can only be 1. So it can be greater, like 4 minus के साथ 3 minus, 4 plus के साथ, sorry not minus, 4 plus के साथ 3 plus का हो सकता है, 2 plus के साथ 3 plus का भी हो सकता है. So it can be with a higher valent, it can be with the lower valent, but the difference in valency can be only 1. 1 से ज़्यादा नहीं हो सकता. It cannot be between 2 and 4. It cannot be between 1 and 3, 1 plus and 3 plus, 2 plus and 4 plus. It cannot happen. 2 plus, 3 plus, it can happen both ways. 3 plus, 4 plus, it can happen both ways. इधर भी हो सकता है, उधर भी हो सकता है. Right? So these are the two of isomorphous substitution, and we all know if it is Si4 plus, that is substituted by Al3 plus. So पहले 4 plus जितना नेगेटिव को बैलेंस कर रहा था, अभी 3 plus उससे एक कम नेगेटिव को बैलेंस करेगा. So it will result in origin of a negative charge. If it is opposite of this, if it is ulta, if Al3 plus is substituted by Si4 plus, in that case पहले ये जितना negative charge को balance कर रहा था, now this will balance one more, so there will be a origin of positive charge. All right, this is very easy. So permanent को हम हटा देते हैं. Coming to pH dependent. Now pH dependent जो charge है वो कैसे आता है? वो कैसे आता है? हम ऑलरेडी बहुत सारा स्ट्रक्चर देख के आए ऑफ एवरीथिंग. यस, सो उसमें जो क्ले एजेस होता है एंड द प्लेन्स, द आउटर प्लेन्स, द प्लेन्स व्हिच आर ओपन, जिसका और बॉन्डिंग नहीं हुआ है, लाइक द बी डायमेंशन में जिसका शीट है, जो लेयरिंग है, it is finite, right? It is not infinite. There is no infinite layering. It is going on for all and all. It does not happen. It is finite. जहां पे खत्म हो रहा है, that exposed edge and that exposed plane, वहां पे जो OH है, वहां पे जो हाइड्रोक्सिल ग्रुप है, that is exposed. That is exposed actually. So that is exposed to the soil solution, that is exposed to the soil environment. अब क्या होता है, soil environment में exposed है तो it is dependent on the pH. How it is dependent on the pH? In the vicinity, if there are lots of H plus ions, lots of H plus ions मतलब pH is very less. pH less है, lots of H plus ion है, तब क्या होगा? तब इसका protonation होगा. Please remember the term, there will be protonation. प्रोटोनेशन में क्या होता है, दिस H plus will come here and it will form this. This is the origin of positive charge, right? This is the origin of positive charge. Now सेम कंडीशन में अगर pH बहुत ज्यादा है, if the pH is high, in that case क्या होगा, too many OH minus are floating around, too many OH minus are floating around. What will happen in that? This OH minus will take this H plus out of this compound and form water. So it will be OH minus plus H plus and it will form water. So if it forms water, what will happen in this? ALO minus. This minus is the origin of negative charge in the soil. So origin of charge we understood. So this origin of pH dependent charge depends on the pH of the soil solution, depends on the pH of the vicinity. So pH अगर कम है, so there will be positive charge. pH अगर ज़्यादा है, there will be negative charge. If the pH is more, it is negative charge. If the pH is less, it is positive charge. So there comes an intermediate pH, which you can see here. Since the soil colloids are amphoteric in nature, amphoteric matlab the exposed hydroxyl groups would be uncharged at an intermediate pH. Amphoteric का मतलब है it can be protonated and or it can be dissociated also. वहां से H plus चला भी जा सकता है, H plus आ भी सकता है, depending on the pH. So depending on the pH, the exposed hydroxyl group would be uncharged at an intermediate pH. That pH is called 0 point charge. That pH is called ZPC. The pH at which the net surface charge of the soil colloid is 0. In this you can see pH जब less है, when the pH is less there is positive charge, when the pH is more there is negative charge. So at an intermediate pH, when all the surface charge will be 0, because similarly यहाँ पे negative हो रहा है, यहाँ पे positive हो रहा है, depending on the pH. So there will be one pH in which it will be 0. So the pH in which the surface charge is 0, the intermediate pH in which the surface charge is 0, that is called ZPC. Now we are coming to the question point of view. In ZPC, permanent charge persists unchanged. This is very important. It underlines the difference between ZPC and isoelectric point. This is also from old ISSS. In isoelectric point, the total zeta potential is 0. That is, all the charge, everything, permanent charge due to isomorphous substitution, surface charge, everything is 0. That is isoelectric point. In case of ZPC, it is only the surface charge which is pH dependent surface charge. If it is not pH dependent, if it is permanent charge, it will persist unchanged. All right. Now this is again a question. This statement ये इतनी बार आ चुका है in PYQs. I have specifically taken this statement for you. Intense weathering shifts ZPC towards higher pH, whereas organic matter pushes it to the lower pH. अब ये क्यों है? If you guys tell me, I will make you understand, or else we will move on. All right. This table is from treatise. इसमें समझाने का कुछ है नहीं. You have to remember this. All right. This is very, very important. You can have many questions from this. This is extremely important. That is why you have to remember. All right. Here you can see this point when the surface charge is exactly 0. This point is the ZPC. If in assertion reason or if in statement type question it comes that ZPC is a pH, please do not forget that ZPC is nothing but it is a pH. So it is on the pH scale. It is a point of pH only. So write it as true. All right. So here there are some information you can see. Altisol and alfisol are rich in have higher ZPC. Inceptisol has low ZPC. ZPC decreases on addition of organic matter, phosphatic fertilizers. Any compound which is more acidic and water that has low ZPC. Now, how this happens, I will tell you very briefly. If you add organic matter will give lots of negative charge. As I already told, organic matter will result in lots of negative charges. For balancing this charge, you need lots of H plus because negative को balance करने का सिर्फ H plus के पास ही ताकत है. H plus only has the capacity to do that. So lots of H plus means pH will be less. So here you can see ZPC decreases. ZPC will be towards the lower pH. In case of intense weathering, it will be the opposite one and it will go towards higher pH. Now the factors affecting ZPC, there is nothing to describe here. You should remember, just refresh your brain. Organic soil has organic acid, organic soil has lots of functional groups, Aishwarya. Those functional groups will supply negative charges. So for balancing that negative charge, you need lots of H plus ions. That is why the ZPC will go towards lower pH. All right. The factors affecting type of clay mineral is number 1. Here I have written it for you. Please be thorough. इसको अच्छे से पढ़ लेना. Organic matter content, I am telling you repeatedly, twice or thrice I have told, contains carboxylic and alcoholic groups, produces negative charge on dissociation, increases negative charge and lowers ZPC. Oxides and hydroxides, Fe and Al oxides, variable charge minerals, high oxide content, high ZPC. Soil pH and electrolyte concentration. This also I explained in detail. If pH is less than ZPC, surface is positively charged. If pH is more than ZPC, surface is negatively charged. Now we are coming to the diffuse double layer theory. Are you guys feeling tired? I cannot see much responses. Yeah, the timing is also not that great. Shall I start diffuse double layer or Shreyoshi? डिफ्यूज डबल लेयर का एक क्विक रिवीजन हो जाए फिर. हाँ संदीप, तो what are you learning from soil science today, huh? Are you liking the lecture, Dr. Sandipto Ghosh? All right, so we will continue only. We cannot waste much time because पढ़ना भी है तुम लोगों को. Very much liking it. Thank you, Dr. Sandipto Ghosh. So the diffuse double layer theory, we all know there are 3 theories: Helmholtz theory, then Gouy-Chapman theory, and finally it is the Stern theory. So इसका जो basic funda है, basic funda I will tell again in very simple way. Double layer theory मतलब there are 2 layers. So there will be layer number 1 and there will be layer number 2. What is this layer number 1? This layer number 1 is the negatively charged soil colloid. That forms the layer number 1. And what is this layer number 2? This layer number 2 is the counter ions. Now how these counter ions, how these cations forms the layer on the soil colloid, that is explained by 3 theories. उसको लेके इतना कुछ पढ़ना है, right? In that, the first is Helmholtz theory, second is Gouy-Chapman theory, and finally it is the Stern theory. ये इतना यहाँ पे definition you can find it in ICAR also. I will not go in detail of that. I will make you understand in my own way. ठीक है? This is the first layer of soil colloid that is negatively charged. This is the second layer of cations or the counter ions that is positively charged. If it is this situation where there is one single rigid layer, this is the Helmholtz theory. All right, this is the Helmholtz theory which was given first. This was the first theory which was given in the first. Then second, what happened? Second came Gouy and Chapman. Gouy and Chapman are 2 different people who differently found it out and published the results in almost same time. That's why दोनों को credit दिया जाता है. उन्होंने क्या बोला? उन्होंने बोला कि first layer तो ठीक है. The first layer is this soil colloid only, but the second layer of cations, that is not rigid. That is not rigid. Instead, it is diffused. Diffused का मतलब है like until the bulk solution, it is diffused. It is diffused and it is interspersed. Matlab, there is no rigid layering of that. This is the Gooey-Chapman. Then who came? Then finally Stern theory came. Stern theory is nothing but it is the combination of the previous two theories, which told okay, this is the first layer and जो second layer है, second layer में there are two subdivisions, 1 and 2. In one, the ions that are very near to the colloid, that will form a rigid layer only. With the increase in distance, this will continue to become diffused. All right. So, Yates का spelling गलत है विपिन यादव. तुम किमेज 10 से पढ़े हो. You should have read it correctly. It's Yates, है ना? So, this is the Stern layer theory in which he told the first layer is rigid, but the second layer is diffused. All right. So, these are the three theories in short. वही चीज सारा इसमें लिखा हुआ है, you know. So, in the Helmholtz layer, there are two fixed layer, one of the charge surface of the colloid. इसको पढ़ के time waste करने का कोई फायदा नहीं है. We will straight go to the graph. This is the most important thing. This is from new ICAR. Here you can see, this is the arrangement of Helmholtz, this is the arrangement of Gooey-Chapman, and this is the arrangement of Stern theory. So here you can see, this is the distance from the particle and the potential. What is the potential? Potential, just now you guys have done the soil physics marathon. In that Purvita have explained the water potential and everything. Potential means the power to do work, potential to do work. कितना पावर लगाना पड़ रहा है, कितना पावर यहाँ पे लगाना पड़ रहा है to get this negative charge out, to take this negative charge out of this electric field, how much power you are providing, that will be the that is the potential. All right. So this layer is having very high potential. सीधी सी बात है, because एकदम the ion that is very near to the colloid, that will be very hard to take out. So you can see the potential here is maximum. Once you go away with distance, it decreases linearly. And when you come here, when the distance of the ions is getting 0, like when the ions are ending, at that place you will get 0. All right. Here you can see, since it is diffused, potential ऐसे linearly नहीं घटेगा, it will be exponential. Like this will have this much, you will need this much power to take this out of the electric field, but for this you will need only this much power. Similarly, this is the combination of Helmholtz and Gooey-Chapman. So here you can see, for the first layer it will go until this and then it will follow the Gooey-Chapman theory. Here there is one question that comes, what is the name of this layer called? The name of this layer should have been Helmholtz layer, but sadly it is not the case. This layer is called the Stern layer. All right, this layer is called the Stern layer and this is the diffuse layer. All right. So if you have read new ICAR, you will see it has been like explained using thermodynamics as well. Thermodynamics देके भी समझाया है Dr. S.C. Datta ने. So here you can see all these ions are tightly bound to the negatively charged clay colloid. So इससे क्या होता है? इससे होता है जो enthalpy है. Enthalpy means total heat of the system. That is minimum. That is minimum. But एक और problem है, that is entropy. Entropy we all know. Entropy is the measure of randomness, right? It is the measure of randomness. Here you can see these cations are not at all random. So enthalpy minimum है, but इसका entropy भी minimum है. हमारा मकसद है enthalpy को minimum करना, entropy को maximum करना. Because again, in universe everyone wants to become stable. And how will it become stable? It will become stable by means of Gibbs free energy, that is denoted by G. It is called Gibbs free energy and इसका formula है H minus T del S. So this H should be minimum and this S should be maximum to make this whole value minimum, because here you can see there is a negative sign. All right. So इसमें problem है, इसका enthalpy तो minimum है but entropy भी मिनिमम है, सो दिस इज प्रोबेबली नॉट करेक्ट। इसका प्रॉब्लम है, इसका एंट्रोपी मैक्सिमम है बिकॉज ऑल द आयंस आर मूविंग अराउंड, इट इज वेरी डिसऑर्डर्ड, बट इसका एंथैल्पी भी, इसका एंथैल्पी जो है दैट इज नॉट मिनिमम, दैट इज आल्सो मैक्सिमम, वो भी बहुत ज्यादा है, दैट्स व्हाई दिस इज आल्सो not minimum enthalpy, that is why this is also not correct. In this case, here you can see enthalpy and entropy optimized to result in minimum free energy. See, soil science का जो experiment होता है, soil chemistry का जो experiment होता है, that we cannot see with our eyes, right? We have to predict. अब ये prediction कैसे लगाते हैं? This prediction we can do through thermodynamics, and we can tell कि इसमें से probably this turn theory is the most appropriate. All right. So this equation I have taken from ISSS. This question is one of my favorites and I ask it repeatedly. The thickness of the diffuse double layer, it may be calculated by the equation. Why have I put this equation? Because this equation will tell you the factors that will affect the thickness of the double layer. How it will tell you? Here you can see this delta, this is the thickness. This thickness is delta. ये जिसके ऊपर डिपेंड करेगा, that will be the factors affecting the thickness of the double layer, right? So what are the factors we will see? Static permittivity, that is a constant. Constant को हम कुछ हाथ नहीं लगाएंगे, उसको हटा देंगे. Boltzmann constant, उसको हटा देंगे. Absolute temperature, we got one variable. Then electron charge, इसका भी electron charge is also constant, इसको हटा देंगे. Number of ions per meter cube, this means this is concentration, इसको भी रखेंगे. And this numerical value of the valency, इसको भी रखेंगे. Now you will see the relation between this. So thickness यहाँ पे हम T से लिखते हैं, thickness. This is directly proportional to the root over temperature, as you can see. है ना? Then again, it is inversely proportional to, all right, and also it is inversely proportional to, right? This question comes in exam very many times. You all know it is opposite, right? Concentration of the counter ions बढ़ने से thickness घटेगा, ये सबको पता है. But what is the relation? The relation is root over C. This you have to remember. Here you can see this N0. This N0 has no square, so it will be, the relation will be root over 1 by root over C, right? So if it is increased 4 times, the thickness would be half and not decreased by 4. But in case of valency, you can see valency में x square है, valency में x square है. So when it will be root over of z square, it will be z only. So it is oppositely. So valency अगर 1 से 2 होगा, then the thickness half हो जाएगा. That will be direct relation. All right. These are the factors affecting. Again, I am very critical with the assumptions. Again, I have taken the assumptions for you. This you should read. इसमें explain करने का ज़्यादा कुछ नहीं है. So the assumptions of double layer are: the charged particle has flat surface without edge effect, and the planar surface is effectively infinite in extent. This is a assumption which is never possible, right? So इसका मतलब this theory is also somewhat shaky because planar surface is effectively infinite in extent. That is not at all possible. Extent sites are uniformly distributed over the entire planar surface, that is the surface charge density is uniform. This is another assumption. Dielectric constant of water is constant. The ions act as point charges. This is also, the interaction between ion is negligible, and the change on the surface is neutralized only by the excess of opposite charged ion. This is also assumption. So you should read this. And इसमें हमने जो factors cover किया, उसमें एक factor छूट गया जो वहाँ पे equation में नहीं था. That will be the dielectric constant. For that I came back. So dielectric constant के साथ you should remember that is a direct relation. So if dielectric constant increases, the thickness increases. Now we are almost on the last part of our lecture. Yes, these are the miscellaneous concepts which are very important. Donan membrane equilibrium, I know all of you have read the definition. So मैं definition पढ़ के इसका time waste बिल्कुल भी नहीं करूँगा. I will just tell you what Donan membrane equilibrium is, है ना? say this is solution A, this is solution B, this is solution A, this is solution B. This has Na plus Cl minus, this also has Na plus Cl minus, लेकिन दोनों का concentration अलग अलग है. This concentration is C1, this concentration is C2. So C1 is greater than C2. Let us assume. If C1 is greater than C2, तब क्या होगा? तब दो चीज हो सकता है. एक, either water will flow from this to this or ions will flow from this to this, because we know in universe everything wants to come in equilibrium. So for equilibrium, this Na plus and Cl minus will go into this side and they will form an equilibrium. After attaining the equilibrium, this C1 will be equal to C2, right? That is very simple. लेकिन problem कहाँ आता है? No, we cannot make a new one. Problem कहाँ पे आता है? Problem यहाँ पे आता है, these two ions are small and these two ions are diffusible, right? This membrane that separates the solution A and solution B, this is a selectively permeable membrane. This is a selectively permeable membrane, right? So selectively permeable membrane के अंदर diffusible ions तो जा सकता है. Now, what will happen if there is a big non-diffusible ion present in one side of the solution? This will influence the activity of these two, and since it is minus, तो ये इसको खींच लेगा. And this flow of ions from one solution to other solution will not be equal. So even after attaining equilibrium, you will not find the same as it was happening before the presence of this non-diffusible ion. This is the normal DDL. This is the, sorry, what? Yes, Vipin, you are correct. DDL has an inverse relation with temperature. There I have told it actually wrong. Here, if you can see in the equation, this temperature is absolute temperature, but the one you are telling, that is also due to dielectric constant only. क्यों? टेम्परेचर जब बढ़ता है तो वाटर जो है, that water will be evaporated, and water is the one with having the highest dielectric constant. So water evaporate होने से क्या होता है? Dielectric constant will go down. Dielectric constant will go down, तो thickness will also go down. That is a indirect relation, right? If the dielectric constant goes up का मतलब और कुछ नहीं है, water ज्यादा हो रहा है, because water only has the like significant dielectric constant that can be taken under consideration. So water अगर ज्यादा हो रहा है, the thickness will be more. So that is the reason why dielectric constant बढ़ने के साथ thickness बढ़ता है. अब टेम्परेचर के साथ क्या रिलेशन है? टेम्परेचर बढ़ने से वाटर चला जाएगा, that will result in less dielectric constant and that will result in, you know, smaller thickness. You are correct. But here in this relation also you can see the thickness depends on root over T of absolute temperature. All right. This is from ICCS only. This equation I have not made. So anyhow, we were in Donan membrane equilibrium. So I think you have understood what is Donan membrane equilibrium. So let us read the statement. Suppose an aqueous solution of an electrolyte consisting of two diffusible ions is separated by a membrane from another solution containing a salt with a non-diffusible ion. Non-diffusible ion, this is the non-diffusible ion. In that case, an equilibrium, the flow across the membrane will stop when the distribution of the diffusible ions will be unequal on two sides. Even the ionic activity product of the equivalent amounts of oppositely charged ions or the ratio of equivalent amount of like charged ions on two sides of the membrane will be equal. This is the statement. You can read this statement from ICCS and you can read the beautiful derivation also. वो कराने का अभी बिल्कुल भी समय नहीं है, because this is a marathon class, this is a revision. So it is telling this and this will not be equal, this and this will not be equal on both sides of the membrane after the attainment of equilibrium. But what will be equal? That you can see. Ionic activity product of the equivalent amounts of oppositely charged ions. That is, activity of this into this will be equal to activity of this into this, and the ratio of activity of this by this will be equal to this by this. You can read that, not a problem, but this is the basic funda. All right. Now coming to Schofield's ratio law. This is also a very, very, very important aspect. So Schofield's ratio law का statement तो we all know. When cations in a dilute solution are in equilibrium with a large number of exchangeable ions, any change in solution concentration will not disturb the equilibrium if the activities of all the monovalent cations are changed in one ratio, those of divalent in the square of the ratio, and the trivalents in the cube of the ratio, right? This statement here is extremely important. Please read this statement very wisely. An important consequence of Schofield's ratio law is the applicability of Donan membrane equilibrium, right? So Donan membrane and Schofield's ratio law are related. Please take out old ISSS, read both the portions. It is very easy. If you face any doubt, you can ask me anytime. You can ask in the comments of this video only after this session ends, and I will reply you definitely, don't worry. And here it is written, this line is also a line of question. Dilution favors the accumulation of divalent cations in the adsorbed phase. More CEC, more is the divalent to monovalent ratio. So you guys will tell me whether you want explanation of the ratio law or should I skip to the next part, because we have very less amount of time. So if you want explanation, I can give you explanation. If not, we will move on. Please, anyone write? I'll wait for some time. In Schofield's ratio law, the cations when in equilibrium with the exchangeable ions, any change in the solution concentration, this is important, solution concentration will not disturb the equilibrium if the activities are changed in this way. All right, you want explanation, so we will give explanation. So I will write the expression directly, है ना? The third bracket or the square bracket, it it explains the activity in the exchangeable phase, and the first bracket explains the activity in the solution phase, right? So this is the exchangeable phase and this is the solution phase. All right, so this is the Schofield's ratio law. अब इसका implication क्या है? What is the application of this in agriculture? The application is huge actually. It is telling that this equal to this is equal to constant. That is what the Schofield's ratio law is telling, right? Even if you alter these ratios such that this is altered by 1, then this will be altered by the square of that. Likewise, if it happens, then the equilibrium ratio will remain constant. That is Schofield's ratio law. Now you may ask, sir, आप square बोल रहे हो, यहाँ पे फिर root over भी दे रहे हो, इसका क्या मतलब है? अरे इसका मतलब यही है, if you alter this by C. Read here. If the activities of monovalent cations are changed in one ratio, those of all the divalent cations in the square of that ratio, है ना? So activities of monovalent अगर 2 से change हो रहा है, अगर 2 से change हो रहा है, then in that case वो 4 से change हो रहा होगा. So 4 is what? 4 is nothing but root over of 4 is equal to 2 only, है ना? So this is the case. अब क्या होगा? Let us consider two cases. One is बहुत ज़्यादा rainfall हुआ और irrigation हुआ. For that irrigation and for that rainfall, the dilution of this takes place. Extensive dilution of this will take place definitely. Dilution होने से क्या होगा? Dilution होने से, say the dilution factor is 4. 4 हम ले रहे हैं because यहाँ पे root है, calculation में easy होगा. So the new dilution, the new activity in the solution phase will be K plus by 4 divided by root over of Ca2 plus by 4. So it will be K plus by 4 and by root over of Ca2 plus by 2. So it will be 2 by 4 K plus by root over of Ca2 plus. So it will be half of the previous ratio, half of the previous ratio. ठीक है, अब हाफ ऑफ द प्रीवियस रेशियो मतलब इसको घटाना पड़ेगा. घटाना पड़ेगा का क्या मतलब है? हाउ विल यू मेक इट लेस? हाफ हम कैसे करेंगे? So since this is a fraction, there are two ways. Either you have to decrease the numerator or you can increase the denominator. Either you have to see. So this is half of this. So for making this equal, for making this constant, पहले में लाने के लिए you have to increase this value. Since this is half of the old value must be increased so that this 2 will cancel out and it returns to the old constant value. तो अब old constant value में पहुंचने के लिए increase करने का क्या तरीका है? Either it will be increased or it will be decreased. ये कैसे increase होगा? This will come from exchange phase to the solution phase. This will go from solution phase to the exchange phase. All right. So that is how. So in case of irrigation and in case of rainfall, this will happen. Also, soil fertility class, so I think it will be later. I don't remember the date exactly. It will be after some days. So did you understand? Can you tell me whether you understood it or not? यहाँ पे एक सिंपल फंडा है, उसको याद रखना. जहाँ पे डाइल्यूशन होगा, एग्जाम में बैठ के तुम इतना कुछ करके उसको निकाल तो नहीं सकते हो. जहाँ पे डाइल्यूशन होगा वहाँ पे मोनोवैलेंट जाएगा, जहाँ पे कॉन्सेंट्रेशन होगा वहाँ पे डाइवैलेंट जाएगा. दिस इज द सिंपल फंडा. दिस इज द वेरी सिंपल फंडा. यहाँ पे अगर सॉल्यूशन फेज में डाइल्यूशन हो रहा है, यू आर गिविंग इरिगेशन, रेनफॉल इज हैपनिंग, सो ऑलवेज रिमेंबर द मोनोवैलेंट विल गो फ्रॉम concentrated to dilute phase and this guy will travel to concentrated phase. In other case, अगर evaporation हो रहा है, if there is evaporation, this part is becoming concentrated. In that case, what will happen? K plus will move to this side and this will move to this side. जहाँ पे concentration ज्यादा है, वहाँ पे divalent जाएगा, जहाँ पे concentration कम है, वहाँ पे monovalent जाएगा, है ना? Now, what is inverse ratio law? Inverse ratio law was given by Matson. This is not that important, but एक line है, तो एक line हम याद रखना पड़ेगा. This is concerned with exchange phase. Here in Schofield's ratio law, this is concerned with solution phase. So similarly, in case of inverse ratio law, we know the ratio law dilution favor divalent. No. How will it favor divalent? अरे यार. हाँ, yes, dilution favors divalent in the exchange phase. What I am telling? अरे मैं बोल रहा हूं जिधर डाइल्यूशन होगा उधर मोनोवैलेंट जाएगा. सो डाइल्यूशन अगर सॉल्यूशन फेज में हो रहा है तो सॉल्यूशन फेज में मोनोवैलेंट आएगा. सिमिलरली द डाइवैलेंट विल गो टुवर्ड्स द एक्सचेंज फेज. दैट इज व्हाट आई एम ट्राइंग टू से. आर यू गेटिंग द फैक्ट? अमन, dilution will favor divalent. Dilution will favor divalent in what? Dilution will favor accumulation of divalent in the adsorbed phase. डाइल्यूशन तो एडसॉर्ब फेज का नहीं हुआ ना, डाइल्यूशन तो हुआ सॉल्यूशन फेज का, लेकिन एक्यूमुलेशन हो रहा है डाइवैलेंट का टुवर्ड्स. सो यू प्लीज अंडरस्टैंड, दिस इज द इक्वेशन. ये एक्सचेंज फेज है, ये सॉल्यूशन फेज है. डाइल्यूशन अगर हो गया, डाइल्यूशन हुआ तो मोनोवैलेंट विल कम टुवर्ड्स डाइल्यूट, बट डाइवैलेंट विल गो टुवर्ड्स एक्सचेंजेबल फेज, है ना? इन अदर वर्ड्स, ये अगर कॉन्सेंट्रेटेड हो गया तो क्या होगा? The divalent will come towards solution, whereas the monovalent will go towards the exchange phase. All right? Why? I told you here, because दोनों को अगर इस फैक्टर से घटा देंगे, so it will be half of the old ratio. Half of the old ratio मतलब ये घट गया है मतलब इसको बढ़ाना पड़ेगा. बढ़ाने के लिए क्या कर सकते हैं? In the solution side, you have to increase the K plus or you can decrease the Ca2 plus. Decrease Ca2 plus कैसे होगा? Ca2 को इधर भेज दो. Increase K plus कैसे होगा? K plus को इधर भेज दो, है ना? Similarly, in case of inverse ratio law, the ratio law considers change in solution phase, whereas inverse ratio law takes into account the disturbance in the exchange phase. So solution phase में disturbance हो रहा है तो equilibrium में क्या change आ रहा है? That is ratio law. Exchange phase में disturbance हो रहा है तो equilibrium में क्या change आ रहा है? That is inverse ratio law. So that is the Matson's. Here also you can see monovalent cations are likely to be found more in numbers on the low charge density, that is the dilute phase, while the reverse is true for divalent cations. All right. Thus, monovalent cations are found more in number in exchange phase of kaolinite, and divalent cations are dominant in exchange phase of montmorillonite. All these are question worthy statements. All right, please remember. These are not important for JRF physical science, I will say, so you can skip this also. So यहाँ से क्या क्या पढ़ना है, this you don't need, but सिर्फ ये याद रखना है, Kerr equation सबसे पहले आया था, then it was Vance law, and finally it was Gapon. We all now know that. You can remember by KVG, which is very near to KBG, which is near to KGB. This KGB was the Russian police force, you know. Mnemonic सबका अपना अपना होता है, so you can make it on your own. It will be KVG, Kerr, Vance law, Gapon. So Kerr was the mass number of the exchanging cations. Applicability range is very narrow. Only this much is important. Vance law introduced the term of mole fraction. Here you can see this is the mole fraction term, and this part is extra than what is here. Additional term of this is there. Here in Kerr equation, only the effective concentration is taken into account. In case of Vance law, mole fraction is taken into account, and the final one is Gapon, which is the most widely used nowadays. It is based on molar equivalent. It is used to characterize soils with alkali hazard. We all know this value is very important. This is also there in the salt affected soil chapter, if you remember. So this is very, very important. This value of Gapon constant only might come from here, not anything else. These are also KVD, Krishnamurti Davis Overstreet, KDO, we all know, KDO, and this KDO gave the nearest neighbor model. This is also very important. Jenny gave the term oscillation volume. We are having refreshing, revising, and Jarusov's complementary ion principle. The exchangeability of a given ion is not constant but a function of its amount in relation to the amount and kind of other cations present. This is also very important. All the three here are very important. If you read the PDF, please remember that. All right. Activity coefficient. This is also an important part. So what is that? Simply I will make you understand. You all know this is the activity. This is the activity coefficient. This is the concentration. So इसका मतलब यही है. आज मैं बहुत बार बोला हूँ कि there is interaction between the cations when there is a solution. एक solution जब है वो अगर effectively dilute नहीं है, it is of some concentration, तो क्या होता है, एक आयन की मोबिलिटी के ऊपर दूसरे आयन का इंटरेक्शन होता है. ड्यू टू दिस इंटरेक्शन उसका जो एक्टिविटी है वो घट जाता है ना. दैट एक्टिविटी इज लेस बिकॉज ऑफ द इंटरेक्टिंग चार्ज ऑफ द अदर कैटायन. दैट इज द रीजन दिस एक्टिविटी कोएफिशिएंट इज ऑलवेज लेस देन 1. इन केस ऑफ इनफाइनाइट डाइल्यूशन, जब बहुत ज्यादा डाइल्यूशन हो तब हम एक्टिविटी कोएफिशिएंट को 1 मान सकते हैं. इन दैट केस activity will be equal to concentration. But अगर infinite dilution नहीं है, in the case when there is some concentration, so if there is some concentration, in that case the activity of the ion will be always less than the concentration, and that is the reason why this activity coefficient is always less than 1. See, in dilute solution activity coefficient approaches to 1 and we take it as 1. Here also you can see a very important statement. F decreases with increase in ionic strength of the solution. जितना concentration बढ़ेगा उतना interaction बढ़ेगा एक दूसरे में, and that will be the reason why the ionic strength बढ़ने के साथ साथ the activity coefficient will decrease, right? These are also not that important for JRF, but still I have taken it. पता नहीं आ जाए कि नहीं आ जाए, you never know. They might simply ask electrokinetic phenomenon. I think you might have read that electrophoresis is there, then electroosmosis is there, then Dorn effect is there, and another one is not listed here. That is the ये क्या है, मैं बहुत जल्दी से समझा देता हूँ. Electrophoresis, I think you all know, it happens in gel electrophoresis, you know, DNA. So it is negatively charged clay particles are free to move and therefore migrate towards the positive electrode. So you will take, I think you have read that part where it is given in ISSS. You take a soil clay suspension here, and if you put 2 electrodes and apply charge, the clay will go towards the positive electrode. That is the electrophoresis. This happens exactly the same in DNA electrophoresis, gel electrophoresis as well. Then electroosmosis. Electroosmosis में हम क्या करते हैं? हम solid clay particles को we stop the movement of solid clay particles by glass disc, and only water can move. So since clay particle is negatively charged, the water containing the counter ion is positively charged, so that will move towards the negative electrode. वही लिखा है, the clay particles having been restricted from movement, positively charged solution of the double layer moves under electric field towards the negative electrode. ये हो गया. अब ये जो यहाँ पे लिखा नहीं है स्ट्रीमिंग करंट, ये क्या है? दिस इज नथिंग बट सी इन केस ऑफ इलेक्ट्रोऑस्मोसिस हम क्या देख रहे हैं? वी आर अप्लाइंग इलेक्ट्रिक फील्ड. हम इलेक्ट्रिक फील्ड को अप्लाई कर रहे हैं, उसके वजह से वाटर का फ्लो हो रहा है. दिस इज अ वेरी स्ट्रेंज फिनोमेनन बिकॉज इलेक्ट्रिक फील्ड के साथ वाटर का लेना देना नहीं होना चाहिए. वाटर कैसे फ्लो करता है? वाटर फ्लोज ड्यू टू प्रेशर डिफरेंस. प्रेशर डिफरेंस अगर होगा तब वाटर फ्लो करेगा, लेकिन यहाँ पे इलेक्ट्रिक फील्ड एप्लीकेशन में वाटर फ्लो कर रहा है. सो ड्यू टू एनालॉजी, जब इलेक्ट्रिक फील्ड एप्लीकेशन में वाटर फ्लो हो सकता है, तब प्रेशर एप्लीकेशन में इलेक्ट्रिक करंट फ्लो हो सकता है. बिकॉज इलेक्ट्रिक फील्ड एप्लीकेशन से इलेक्ट्रिक करंट फ्लो होना चाहिए था, उसकी जगह में इलेक्ट्रिक फील्ड एप्लीकेशन में वाटर फ्लो हो रहा है. सो सिमिलरली प्रेशर एप्लीकेशन में probably there will be flow of electric current, and that current which forms, that is called streaming current, and the potential difference is called streaming potential, right? And lastly, it is the Dorn effect. These four are the electrokinetic phenomena. This Dorn effect is nothing but the reverse of electrophoresis. This is a very important part. I think all this have been covered in the master course. Who are the master course students? You know already. So this is the reverse of electrophoresis. Reverse of electrophoresis का मतलब क्या है? यहाँ पे हमने electric field apply किया, the clay particles moved. यहाँ पे क्या होगा? यहाँ पे the clay particles are moving. That is resulting in electric field. In 1878, Dorn discovered a relative phenomenon in which collateral particles under sedimentation in water leads to the development of an EMF. वहां पे EMF देने की वजह से clay particle का movement हुआ, यहाँ पे clay particle के movement की वजह से EMF का development हुआ. That is the Dorn effect, right? Finally, we have come to the lyotropic series after so long. So it defines the adsorbability of cations to a charged surface. इसको लेके we talked about in the first phases of the class also. It defines the adsorbability of cations to the charged surface. So monovalent cations ka, this is the one I already told you. Most dispersive is lithium. Divalent cations ka, this is the series, and of variable valency, all of you know, this is the perfect lyotropic series, also called Hofmeister series. In the presence of salts, cation exchange is regular, follows lyotropic series, and is irregular in the absence of salts. This is taken from TD Vishwas. This is a very important question because TD Vishwas से बहुत सारे question आते हैं JRF में. So here you can see, in the absence of salt, CEC decreases in the following order, which does not follow any pattern. Wherever in the presence of salt, it follows the regular pattern. All right. Now ligand exchange. Ligand exchange we will cover in detail in phosphorus. So here I will just tell you, the ligand is an anion or a neutral molecule. Ligand can be both anion or neutral molecule. Yes, that satisfies the secondary valency of the coordination number of a central cation in a crystal lattice. In FeCl3, 3 Cl minus ion satisfy this. If you tell, I will explain. Otherwise, we will move on to the new part. Is anyone there? I don't think. Next. Pawan is telling explain. Aman is telling next. Kya kare? We'll see. If we have time, we'll explain. This is the last portion of the lecture, you know, submerged soil. Submerged soil are saturated or waterlogged soil where oxidation reduction processes dominate. 72% of Earth's surface is submerged soil. And sediments, there are 4 types of submerged soil: waterlogged, marsh, paddy, and subaquatic. So I have only taken the points to remember because submerged soil से बहुत ज़्यादा question नहीं आते, जो आता है I have taken that only. O2 H2O system has the highest standard redox potential. Yes, we all know that. Redox potential is defined as the tendency of a system to get reduced. Tendency of a system to get reduced, and it is denoted by EH. All these are question worthy. The resistance in change of redox potential is called poise. It is called poise, and it is defined by amount of electrons as reducing substances that must be added to result a unit reduction in redox potential. All right. A well-poised system, small change can occur only when large addition of reducing substance is there, because poise मतलब resistance. It is kind of like buffering. तो buffering अगर ज़्यादा है तो you have to give large addition, अगर तभी जाके small change होगा, नहीं तो नहीं होगा, है ना? Concept of electron activity or PE. PE is defined as PE is equal to minus log of electron activity. We all know it is the same as pH only, minus log of H plus ion activity. So it is the negative logarithm of electron activity. अब इसका 2 फ्लो चार्ट में पूरा समझा दिया गया है. हाई इलेक्ट्रॉन एक्टिविटी मतलब दिस इज वेरी हाई, दिस इज वेरी हाई मतलब दिस इज वेरी लो. So high electron activity means very low PE value, means highly reduced state, high tendency to get oxidized, reduce others. Clear? Low electron activity, this is low, means this is high, high PE value, highly oxidized state, high tendency to be reduced and oxidize others, right? This table is बहुत ही ज़्यादा important. I cannot explain how much important is this. You can definitely expect questions from here, either in statement type or assertion reason type or match the following type. कुछ भी आ सकता है यहाँ से, ठीक है? So you have to remember, this has been taken from Dr. S.C. Datta's book, Soil Physical Chemistry and Mineralogy of Soil. So in this pH 7 values you have to remember. Here the pH 5 values are also given, but you have to remember the pH 7 values. pH 5 values भी तुम याद रख सकते हो. It depends on you. And here you have to remember the sequence: oxygen, nitrogen, manganese, iron, sulfur, carbon. All right. Here I have given some extra points for you. The redox potential is measured by dipping an inert metal such as platinum electrode again. To complete the cell, a reference electrode is needed. This reference electrode ideally is hydrogen electrode, but practically it cannot be used. Practically we use calomel electrode, or which is Hg plus Hg2Cl2 plus KCl. All right. This is the graph of change in redox potential of submerged soil with time. Only remembering this graph is enough, because from this graph only they might ask question and there will be nothing else. अब ये क्यों होता है? I will explain that very short. ऐसा क्यों होता है? You can see for the first few days this decreases very high, very steep decrease. Why? Just after submergence, जितना भी organic matter बचा हुआ था, उसका decomposition becomes very rapid. It becomes very rapidly decomposed by the microbes. The microbes start decomposing that. EH is redox potential. P is electron activity, logarithm of electron activity, P, है ना? So the microbes start decomposing the organic matter very rapidly. उसके वजह से क्या होता है? This organic matter gets oxidized. We know decomposition से oxidized होता है. This organic matter is getting oxidized and it is losing a lot of electrons. बहुत ज़्यादा इलेक्ट्रॉन वो छोड़ रहा है फील्ड में. अब वो इलेक्ट्रॉन छोड़ रहा है फील्ड में, सबमर्जेंस अभी हुआ है, सो द स्पीशीज, सबमर्जेंस अभी हुआ है, तो द रिडॉक्स पोटेंशियल क्या होगा? देयर आर लॉट्स ऑफ इलेक्ट्रॉन्स अवेलेबल, बट वो इलेक्ट्रॉन एक्सेप्ट करने के लिए वहां पे कोई स्पीशीज नहीं है. देयर इज नो स्पीशीज. द Fe, iron, manganese, these are not ready yet. These are not ready yet to accept the electrons. तो क्या होता है? Since these are not ready yet to accept the electrons, the region becomes highly reduced. बिकॉज बहुत ज्यादा इलेक्ट्रॉन का कॉन्सेंट्रेशन है, इलेक्ट्रॉन का एक्टिविटी है और उसको लेने के लिए कोई नहीं है। तब क्या होता है, देयर इज अ शार्प डिक्रीज इन द EH। तब क्या होता है, दिस यू कैन सी, दिस इज द टाइम in about 2 weeks after submergence. In 2 weeks you can see from 900 millivolt it falls to almost minus 400. Then what happens, then these iron, manganese, all these they start to become active and mobilize their poise capacity. इसका मतलब क्या है, जितना भी oxidized था, now they will start accepting the electrons, and they will get reduced. So अब इलेक्ट्रॉन एक्टिविटी, द इलेक्ट्रॉन का जो कॉन्सेंट्रेशन है वो घट रहा है, द इलेक्ट्रॉन एक्टिविटी इज गेटिंग रिड्यूस्ड, सो अगेन इट विल स्टार्ट इंक्रीजिंग, and after that, according to the characteristic of the soil, the EH will attain the value that it had to attain after submergence. All right, so explaining this part is the key, like why it happens. All right, इसके बाद इसमें एक और ही ग्राफ है, you all know, that is the pH. All of you know that submergence में pH comes towards neutrality. All right, pH comes towards neutrality. Acidic soil अगर है, its pH will increase. Basic soil अगर है, its pH will decrease. Why? How? यहाँ पे लिखा है, in case of acid soil, this is in case of acid soil, decrease in pH shortly after submergence, accumulation of CO2 by respiration of aerobic bacteria. Accumulation of CO2 से क्या है, H2CO3 formation होगा, it will decrease the pH for a very short time, shortly. उसके बाद क्या है, subsequent increase is due to reduction of Fe and Mn. Just after submergence, जितना भी pH acid soil का था उससे और थोड़ा नीचे जाएगा, it will decrease a bit again, then it will start to increase. Why? Due to reduction of Fe and Mn. All redox reaction consume H plus ions and so pH increases. All redox reactions take place in this way, be it Fe, be it Mn. So along with electron, it will consume H plus as well. And we all know the definition of oxidation and reduction. If we are consuming H plus, we are getting, oxidation reduction में चला गया मैं, pH. If you are consuming H plus, pH is increasing because H plus activity is decreasing. So this rate of increase in pH, this line is very important. This rate of increase in pH depends on the ratio M by N, that is H plus by electron, and not alone on H plus. All right. This is the case for acid soil. Now what happens for alkaline soil? In alkaline and sodic soil, dominating influence is of dissolved CO2 to depress the pH on submergence. Alkaline soil में we know, alkaline soil में कहाँ से iron manganese लेके आऊँगा? Alkaline soil is either calcareous or it is sodic. So majorly it is CaCO3 and Na2CO3. So CaCO3, H2O, CO2, this buffer system will generate H2CO3. That H2CO3 will reduce the pH. This buffer system in case of sodic soil, this will also generate the H2CO3, which will reduce the pH of the sodic soil. So in case of alkaline soil, the pH will go down because of these two systems. In case of acid soil, as I told, consumption of H plus in the reduction reactions, the pH will go up. So on submergence, all the pH goes towards neutrality. So finally, we have come to the question answer part. Now it is up to you. All these are PYQs. I have not made up any question. I have not taken any ulta palta question from any side, right? So you guys have to start giving me the answers. Which gas is emitted from the soil due to rice cultivation? Aman, I will tell. Please complete the questions. We'll complete the questions in 10-20 minutes and then we will discuss. है ना? We'll definitely discuss. You keep it noted, I will tell you. Why low PE is an electron donor in system? So iska answer everyone knows, methane, because just few slides back I told you, you have to remember this table anyhow, and upon submergence, this is the reaction that emits methane, right? So, and what will be the answer of this? I think zeta potential I have missed. Zeta potential I have missed while I was telling the DDL. कोई बात नहीं, zeta potential तो तुम सबको पता ही है. I will tell it again, no worries. So इसका आंसर होगा zeta potential. Yes, very good. This one. Match the following. Please match the following. I think you are having no problem in seeing the questions. Are you having any problem? No, I guess. What about question 75? Under what condition denitrification is a major mechanism of nitrogen loss from the soil? All these questions, for your information, are from JRF 2020. मुझे पता है आप लोग जो recent question है 24, 25 सब एकदम करके बैठे होंगे, तो I have taken from the older ones 20, 21, 22 like that, है ना? Under what condition denitrification is a major pathway? अरे बताओ यार, it's so easy. Yes, Aman, इतना क्यों time लग रहा है भाई? Today only we read, again we will study this in nitrogen, you know. It will be submerged soil, because submerged soil में again the answer is the same. एक ही टेबल से मैं बोल रहा हूँ, एक ही टेबल से we already got 2 questions, है ना? Yes. So be very thorough with this table. The K bearing mineral dominated in soil. ये तो आज बहुत अच्छे से बोला गया है. I would expect all of you to answer. Yes, of course it will be mica. इसमें तो कुछ सोचने का बात ही नहीं है. What will be the next one? Yes, please write the answers. ऐसा ऑप्शन नंबर मत लिखो, छोटा छोटा आंसर है, आंसर ही लिख दो तो इजी होगा for me to understand which one you are trying to say. Pawan, that's very sad. You are making this as wrong. It's so sad. Which one of the following is 2:1 non-expanding clay mineral? This is what happens. This is what happens. You will study so hard, you will do all the hard questions correct, and then you will get trapped in a question like this. That is the sad part. That is the very sad part. Reading it quickly तो नहीं करना है ना भाई. You have to read the question thoroughly and then you have to answer. यहाँ पे कितना अच्छे से लिखा हुआ है. The question setter is so nice. He has written नॉन एक्सपेंडिंग देख के कैओलिनाइट नहीं मारना है. अभी तो तुम्हारे लिए और भी गलत चीजें पड़ा हुआ है. This question is from ये दोनों क्वेश्चन एक के बाद एक रखने का यही मतलब था. Can you answer this? Now Pawan is telling kaolinite. So all of my seniors, जितने भी मेरे seniors थे, all of them marked kaolinite, but NTA has given the answer as illite, and kaolinite they have not given as the answer. Even after repeated challenge, at least 7-8 people have challenged who I know personally. Still they have not changed the answer key. Yes, Aishwarya, I understand. Kaolinite is the more appropriate answer. Why not illite? Illite भी होगा ना भाई. Illite is also there. But yes, no, NTA तो बॉस है. NTA जो करता है. अब NTA का वहाँ पे explanation यही था. NTA does not care to give any explanation anyhow. But apparently this line is directly taken from TD Vishwas. If you read TD Vishwas, this line is directly from TD Vishwas, and in that line they have written it as illite. वहां पे illite है तो illite होगा. And they are like, it is so such an injustice के they have not even, after challenge they could have included, no. After challenge they could have included both 2 and 4, but they have not. They have not taken 4. So ऐसा क्वेश्चन एक दो आता है यार, थोड़ा दिमाग ठंडा रख के कर लेना उसको, है ना. Match list 1 with list 2. ये AI से करने के वजह से ये सब थोड़ा सा हुआ है, प्लीज बियर विथ मी, है ना? प्लीज 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 फास्ट. प्रेजेंस ऑफ K इन द इंटरलेयर स्पेस कौन सा मिनरल है? Mg ions are adsorbed between the crystal units कौन सा है? प्रेजेंस ऑफ वन ब्रूसाइट लेयर कौन सा है? 2:1 टाइप एक्सपेंडिंग कौन सा है? दिस इज एक्सट्रीमली इजी, इसमें कुछ करने का नहीं है, वी ऑल नो ये विल बी 3. ये बोल्ड करके भी रखा है, सी, सो नाइस. सो या, वी ऑल हैव डिस्कस्ड दिस टुडे. व्हिच ऑफ द फॉलोइंग इज not related? All these are JRF 2021, you know, all these are JRF 2021. Which of the following are not related to anion exchange capacity? Dissociation of carboxylic and phenolic group on broken crystal edge, dissociation of OH ions from ALOH group on broken crystal edge and addition of H on these sites, dissociation of OH ions from ALOH group on broken crystal edge and addition of H on these sides. Same option they have given twice. Wow, NT again. Addition of H on humus missile. So Vipin Yadav is telling option A. Yes, definitely it is option A. Not related बोल रहा है. Not, again please read the question. Not related बोल रहा है. Dissociation of carboxylic and phenolic group से क्या होगा? उससे negative charge develop होता है. So negative charge अगर develop होता है, it will not be related to anion exchange. It will be related to cation exchange. So in this I could not see many answers. Only Vipin is there. That is kind of sad. But anyhow, ठीक है. This question, first we'll answer this question. This I have emphasized a lot. I have emphasized a lot. Please tell me what is the answer of this question. Yes, I told it many times today. It will be option 3, and all this should be in the tip of your list, because you can see these are all previous year questions only. I have not made these questions, or no one has made. All these are PYQs. Right? So iska answer hai option 3. We got it. We discussed it in detail today. Now we will go to this question. Is question mein I have not given the options because jagah nahi tha. So you just write kaun sa true hai, kaun sa false. You can write it like TF, or you can write 1 true, 2 false, like that. Whatever you like, but write. Permanent negative charge result from isomorphous substitution. Permanent negative charge result from exposed crystal edge. That is like, it is a kid level question. Like someone studying in class first year only, say. First year UG. Where are the answers? Definitely it will be 2 false, because same statement do baar de diya hai. Of course this is true, this is false. This we have read in detail. Both true. What Spurti? Please read the question. Please read the question. दोनों में same है. Permanent negative. Permanent negative. Do not be in a hurry. बहुत समय है. Read the question. Again, now we will come to this question 13. इसका answer. The permanent charge of silicate clay mineral result from isomorphous substitution. pH dependent charge depend on dissociation of H plus from the edge. See, these questions are side by side. I think this is, I think, 2022 and this is 2021. See, someone in the chat always asks, no, कि sir PYQ repeat होता है, तुम्हारे आंखों के सामने है. See, PYQ repeat हुआ है and it is exactly the same. You should be very thorough with your PYQs. इसका क्या आंसर है? इसका आंसर क्या है? Option 3. This one. Permanent charge of silicate clay mineral isomorphous से होता है, pH dependent dissociation of H plus से होता है. This will be both true, no? What are you thinking so long? This will be both true. And you are giving answer to this question. I can understand. This is also very easy. This is the CEC. This question I have specifically taken for you guys, because this has been a trend nowadays. They are asking questions like this a lot. They are asking questions like this a lot. So it would be my suggestion to please make a list of the books here. See if you can do this, and that's why I have also taken this book for you guys to know. Jitna bhi kitab hai related to chemistry, you should be very thorough with that. You should make a list. All right. This book is Physical Chemistry and Mineralogy of Soil, written by S.C. Datta. Then there is one book that is called Chemistry of the Soil, that is written by B.R. Then another book is there, that is The Chemistry of Soil, that is written by Sposito, you know. So you have to be very thorough with all these books and their writers, है ना? And please make a list. यहाँ से match the following आने का chances are very high, huge chances there. So all the books related to chemistry, ये दोनों तो हो गया. Then Kimage-Tan का book जो है उसका नाम क्या है? What is the name of the book of Kimage-Tan? Which we all should study, लेकिन हम लोग पढ़ते नहीं है, वो अलग बात है. Yes, option C तो ठीक है. What is the name of the book written by Kimage-Tan? Principles of Soil Chemistry. Very good. इसका करेक्ट आंसर होगा ऑप्शन सी, है ना? These are all of my favorite questions, you can tell. इससे स्टार्ट करते हैं. This, since these two are calculations, we'll start with this. This also has been taken exactly from TD Vishwas as it is. If you open the TD Vishwas, this statement is there as it is. This has been taken. This is 2022 Physical Science JRF. Can you tell me what is the answer of this? Exhaustive hydrolysis and leaching in desert soil leads to the formation of dash clay minerals. Kaolinite. Pawan is telling kaolinite. Aman Kumar is telling kaolinite. Very good. This is also from TD Vishwas and it is as it is. Many of my seniors, many people, they have marked it as option 1, illite, because majorly we know in desert soil we can find illite, but kaolinite is the answer because it has been taken directly from TD Vishwas. All right. Now we will come to this question. This question is very easy. This is also from 2022. Here you can see. So a solution of 0.30% is equivalent to how much ppm? You should be very thorough with your basic chemistry. I don't know whether there will be a basic chemistry marathon or not. If you guys want it, you please let us know. You please write in the comments of this video, not in the live chat, but in the comments. Can you please tell me the answer? Anyone? Nikhila only is telling option 1. It is very easy, no? What is there to think about? ppm means parts per million, है ना? Parts per million means 1 by 10 to the power 6. 1 by 10 to the power 6. Percentage means 1 by 10 square. अब दोनों का डिफरेंस क्या होगा? 6 minus 2 क्या होता है? 4. So you have to multiply with 10 to the power 4. तो 0.3 है into 10 to the power 4 करो, 3000. It will be option. अरे ऋषि मुख फार्मा, this is not State Bank, huh? So yes, it will be option 1. It will be into 10 to the power 4, है ना? So since it is 0.30, it will be this. Now we will come to this question. This question is also from JRF 22. Let's see if you can answer this. If you can answer this, I will be very impressed. Otherwise, I will have to solve it for you. No problem. Has anyone been able to solve this question till now? Or should I solve it for you? Tell me in the comments. Aman is telling option A. Okay, I can see only one answer. This is a legit PYQ and I can see only one answer. That is very heartbreaking. Like, you guys have not practiced PYQs or what? PYQ should be in the tip of your fingers. Otherwise, rank लाने में थोड़ी सी दिक्कत हो जाएगी, you know. This is how it will dissociate. All right. So let us assume the solubility as S. So this will be S, this will be 2S. So in equilibrium, the solubility product will be right. So it will be this is the equation, right? So अब KSP का जो value है, KSP का value दिया गया है ना? Solubility product का value है 3.2 into 10 to the power minus 8. 3.2 into 10 to the power minus 8. 3.2 into 10 to the power minus 8 is equal to 4s cube. So s cube is equal to 3.2 by 4 into 10 to the power minus 8, which is equal to 32 by 40. That is equal to 32 by 4, matlab 8, and this 10 will come here. It will be 10 to the power minus 9. So s cube is equal to 8 into 10 to the power minus 9. So s will be equal to 2 into 10 to the power minus 3. This one is very easy. It is class 11 level question and I can see only one answer. That is extremely heartbreaking, but I hope you guys will practice your basic chemistry because basic chemistry se bahut question aata hai, you know, and you have to be very thorough with basic chemistry. If you want marathon of basic chemistry, you can please let us know and we will try to arrange that. Okay, we have only 2 more slides. So please tell fast and we will end this session. This is elements trapped in between precipitate particles is called. Is anyone there? Elements trapped between precipitated particles is surface attraction, occlusion, precipitation, inclusion. What will be the answer? Are you there, Aman? Occlusion. Yes, the answer will be occlusion. What is the normality of HCl if छोड़ो ये तो बेसिक केमिस्ट्री का क्वेश्चन है, नॉट सॉइल केमिस्ट्री. विल लीव दिस, वी विल डायरेक्टली ये भी हम छोड़ देते हैं. दिस इज द इलेक्ट्रॉनिक कॉन्फ़िगरेशन. दिस इज वेरी इजी आई गेस. मैग्नीशियम इज, we know the atomic number 282, then lithium is 3, this will be Na and this will be chlorine, right? So this is very easy. This one I think all of you can answer. Minerals have a definite chemical composition, that is a true statement. Then minerals are inorganic in nature, that is a true statement. Atoms that make up minerals are not arranged in an orderly pattern, that is false, not likha hai yahan pe. Minerals are the building blocks of rocks, that is also true. The correct answer will be A, B and D. All right, it will be A, B and D. 91 you have calculated, very good, very good. If you have calculated, this is also very easy. We all know the formula, right? N1V1 equal to N2V2. This is also basic chemistry. If you guys want basic chemistry class, please write in the comment of this video, not in the live chat, write it in the comment and we will arrange it for you. So this is also a proper soil chemistry question. Olivine is least stable. It has independent silica tetrahedron and held together by forming bonds with hydrolyzable Mg or oxidizable iron. What will be the answer of this? You can write like TF. Both correct. This is a very easy question. Yes, you are right. So we are on the last slide and these are all, you know, very important chemistry questions. So phosphorus is immobile in soil because phosphate ions are held by anion exchange, held by ligand exchange, adsorbed as sparingly soluble phosphate of FeAlCa, leached as completely soluble phosphate. इसमें से कौन सा correct है? Definitely option D, like this is a wrong statement. So A, B and C will be correct only. Here, what is the common formula for alkane? We all know. All these are alkanes. We all know it will be CnH2n plus 2. This is JRF 2023. This was on my time, my JRF. This one, this one, this one, this one, please solve. Cations adsorbed on soil colloids determine aggregate formation. This is true. Cations form electropositive links between electronegative soil particles. This is also true. So this will be option 1. Both A and R are correct and it is the correct explanation. Arrange the hand. This I tell you always, that table I was emphasizing today earlier in the class. See उस table का कितना महत्व है, उस table से कितना सारा question already आ गया. So which one you are telling? Option 4, Pawan? इसको ऐसे solve कर देते हैं भाई, option देखने का जरूरत नहीं है. Attachment of Ca2 plus Na plus is dispersion. This is pH dependent. Attachment is ionic double dash, है ना? This will be the answer. For this, arrange the following in decreasing order. Decreasing order of number of linkages. Decreasing order, ज्यादा से छोटा. So सबसे पहले रहेगा नेसोसिलिकेट, सबसे लास्ट में. So यहाँ पे अरे सारा ऑप्शन तो नहीं दिख रहा है. So ऑप्शन देखने का जरूरत नहीं है. We will write it. A will be in the last. Then it will be D. Then it will be B. Then it will be C. So it will be CBDA, है ना? CBDA, option 2. So that ends the session of today's class. That was a huge task to cover whole soil chemistry in just 3 hours. It is very difficult, but I tried my level best, and I would be very happy if you let me know if there is anything that I could have improved or anything that you would have expected me to do better. And also, one thing that I missed, I would like to explain that. Shomik Paul, what is occlusion? अरे यार तुम बाद में क्यों पूछते हो? When the question was happening, I told you no. Occlusion का definition ही तो दिया था. They asked the normal definition of occlusion. See, elements trapped in between precipitate particles. It is called occlusion. You have not heard the occlusion. Occlusion of nutrients inside the minerals, जिसके वजह से that does not come out. Micronutrients का occlusion होता है. बहुत सारे nutrients का occlusion होता है. That is occlusion, है ना? So I will go to the double layer, and I have missed one part that I will very quickly say. That is, I think all of you know already, इसमें कुछ बोलने का नहीं है. That will be zeta potential, right? Zeta potential I have not told, that I have missed, but if you come here in this slide, zeta potential is nothing but, zeta potential is the potential difference between, zeta potential is the potential difference between the fixed layer and the mobile layer. So this potential difference is called the zeta potential. It governs the stability of the soil colloids. If you open the old ISSS, उसमें बहुत अच्छे से definition दिया गया है कि this potential difference between the fixed layer and the diffused layer or the mobile layer of the double layer, that potential difference is called zeta potential. Zeta potential governs the stability of the clay colloid. Zeta potential agar if it decreases, then the clays will flocculate. If it increases, then there will be dispersion. Sir, one section of basic chemistry and basic principle of instrument. यहाँ पे मत लिखो भाई. You write it in the comments so that the AgriAddict team can see that, and we can take. Please write it in the comment of the video. Next class timing. Next class I will take fertility. Fertility class will be, I think, after 2 days. Today is 9th. Fertility will start on 12th. We cannot do it on one day. We have to we have to take 2 sessions. Fertility is huge. Nitrogen, phosphorus, everything we will do. We will do in detail. जहाँ जहाँ पे ज़रूरत होगा. So that is zeta potential. Yes, it is indirectly proportional to valency. Counter ion का valency जितना ज़्यादा होगा, उतना कम होगा zeta potential, and there will be flocculation of clay. We all know. This Purvita has also covered in soil physics. That one flocculation is aggregation is flocculation plus. This plus is cementation. That was told by Richard Bradfield of Cornell University. All these are very basic questions in our MSc. So Baki, I think I have covered everything. Ligand exchange, you guys only told कि उसको skip करके आगे जाओ. What type of question will come from this diagram? अरे भाई यहाँ पे सब कुछ ही तो question है. Everything is question. They can ask this. Sir, what is a good book for agrochemicals? Agrochemicals का good book तो यार in JRF level, I think internet source and physical science booster, if you have, that will be the best one. Physical science booster is very good. If you do not have that, then there is one book. It's called Objective Agrochemicals by Orkodev Mukhopadhyay. Mukhopadhyay only. It is written by chemical PhD students of IRI. That book you can see. You can get it from Pusa bookstore, or also it is available online also. It is called Objective Agricultural Chemicals. That you can see. It's a very small book. It's like Nimrat Sunda only. Sir, for how many hours the class been going on? It is going on for 3 hours 9 minutes. You are late by 3 hours 9 minutes. So if there is not anything else, I would like to close the session. And if you have liked it or enjoyed it, please let me know, because that will only motivate me. I have no other reward for this, and we'll end the session.